it is our privilege to extend our warmest welcome to our esteemed guest, whose contribution to academia and research inspires us all. As a token of our appreciation, we now proceed with the felicitation ceremony. May I kindly request Konkita to please felicitate our esteemed guest, Chairperson of our conference, Professor P. N. Deka, sir, Dean of Science and Engineering, Professor Gitika Bora, ma'am, Director Duet, Dr. Mukul Chandra Bora, sir, Dean of Student Affairs, Professor Surajit Bor Kotoki, sir, Professor Ankur Bharali, Director IQAC.
With us, two experts are also present here. Professor Manoj Kumar Deka from Assam Scale University, Dr. Bhaskar Deka from Guwahati University. So, may I request our Dr. Niranjan Bora to kindly felicitate Professor Manoj Kumar Deka. May I request Dr. Niranjan Bora to felicitate Dr. Bhaskar Deka. Thank you so much.
The lighting of the lamp signifies the illumination of knowledge and wisdom. As we embark on this journey of learning and discovery, I invite our esteemed dignitaries to join us in the ceremonial lighting of the lamp.
To formally welcome you all to this prestigious conference, I now invite Dr. Kaushik Das to deliver the welcome address.
Good morning, respected teachers, guests, dean, chairperson, director, duet, HODs, esteemed faculty members, research scholars, my dear friends and my dear students. We welcome you all to the first national conference on the multidisciplinary approaches in networks and computing. This national conference was initiated actually with a very short story. So a mail was received by our Honorable Vice Chancellor, Dibrugarh University, who actually motivated us to organize a national conference with a multidisciplinary theme. As we all know that engineering is incomplete without science, basic science, mathematics, physics, chemistry. So this was our first step with a multidisciplinary approach. With this initiative, a committee was formed and I was appointed as the proposed organizing secretary. I am introducing myself, that's why. I am Dr. Kaushik Das, working as an assistant professor in the Department of Computer Science and Engineering of Dibrugarh University, DUET. So, as the duty has been entrusted, and I would like to welcome you all. I hope everyone will be benefited by listening to our keynote speakers and plenary speakers and the invited speakers who have traveled a long distance to reach our university. I request all the research scholars and students to take it as a privilege so that they can acquire as much knowledge, they can exchange their knowledge, and also please help us to make this conference a successful one. Without your support, this conference cannot be a successful one. So with this, I would like to introduce the conference that we have 4 tracks: artificial intelligence and machine learning, network and computing, computational mathematics, computational techniques in applied sciences. So the abstract presentation will be held on this 2-day national conference, and post national conference we have already approached 2 journals and 1 book series chapters where we will try to publish as per the selected criteria. So with this, I would like to thanks again to the sponsors who have supported us, like State Bank of India, Punjab National Bank, and may I request the volunteer anchor to proceed with this session. I once again welcome you all, welcome all the authors and participants. Wish you a grand success.
Thank you, Kaushik sir, for your warm welcome address. Now, as we move on to the next, leadership and vision are the cornerstones of academic and research excellence. We are honored to have with us an esteemed chairperson whose insights and guidance have been instrumental in shaping this conference. Please welcome Professor P.N. Deka sir to share his thoughts.
Good morning. Honorable Dean, Science and Engineering, Professor Gitika Bora. Honorable Dean, Students Affairs, Professor Surajit Brakotaki. Or respected head of the department, respected head of the department, respected Dean, respected Director, Professor Director Duet, Professor Mukul Chandra Bora, respected Director IPSC, Professor Ankur Bharali, respected guest, respected faculty members, research scholars, and most importantly, the participants of the conference. I welcome all of you to this two-day national conference on multidisciplinary approaches in networking and computing. This conference is organized with the aim to give opportunity to our research workers who are working particularly in the area of computer science and mathematics, in the area of multidisciplinary approach in networking related to the computer science, and those who are using mathematics, using computer techniques, computer tools in their research in the Department of Mathematics, in the area of mathematics. So with this specific topic, we have organized this conference, and we as we see that in the last 3 decades, the researchers in mathematics are more and more connected with the computer science. They are working in area dependent on wholly or partially on the computers. So our aim is to bring together these researchers and to give exposure of the current trends in this area. Further, in the Department of Computer Science and Engineering, more researchers are involved in the area where mathematics is directly connected. So one of these aspects was the multidisciplinary approach in networking. So this aim will benefit our researchers who are working in our university as well as in other parts of the country. So we get benefited to develop new ideas in our research. I can mention it here that the Department of Mathematics, Dibrugarh University, is one of the oldest departments where computers were installed, where computers were first installed for the use of researchers. It is a long history. So our researchers were privileged in the early time to use computer techniques in their research. And now, till now, the trend is continued. And we have been working, many of our researchers are working in this area with new techniques. So I think our students as well as other parts of the country, those who are working in this area, will give us feedback for this conference. during the last 3 decades, the research in mathematics are more converging computer-centric. So this trend has to be maintained. So with support from the authorities, the universities, and the government, and we can make new knowledge, new technique, new innovative ideas to our students if we can work, we can get facilities to work in the research areas, so that students are getting exposed from our knowledge to these new innovative ideas. The Department of Computer Science and Engineering, which was established in the year 2009, has been actively working in this regard, in this direction, and within very short time, this department is emerged as an important department, not only in this region, but also in the country as a whole. I hope the research across the country, participating in this conference will be able to get academic benefit up to their satisfaction by participating in various sessions. I wish that all participants will actively involve in the sessions, so dissemination of their knowledge and also through interaction. So these are the few words I want to convey to the participants. I wish a comfortable and enjoyable time during this 2-day stay of our participants. Thank you.
Thank you, Professor P.N. Deka, sir, for your insightful words. Now I request Dean of Student Affairs, Professor Surajit Borkotoki, sir, to share some few words on this conference.
In the meantime, let us take it as per the schedule. So may I request our Honorable Dean Science and Engineering, Professor Gitika Bora ma'am, to kindly deliver ma'am's inaugural speech.
Namaskar. A pleasant good morning to one and all present here. Respected Professor Deka, Head Department of Mathematics and Chairperson of this conference, Professor Borkotoki, Dean Students Affairs, Dr. Bora, Director, Duet, Dibrugarh University, and other dignitaries in the audience, faculty members from Duet and other departments of Dibrugarh University, researchers coming across the country, students' friends, and media person, if any, and technical staffs. I feel privileged to welcome you all to this inaugural function of this 2-day National Conference on multidisciplinary approaches on networks and computing. The Dibrugarh University Institute of Engineering and Technology, shortly DUET, a constituent college of Dibrugarh University, was established in 2009 with due approval from the government of Assam. It has 5 different departments, and I feel very proud that last 15 years DUET has made a commendable progress in the field of research and patenting. I feel extremely proud that the Department of Computer Science and Engineering of DUET and the Department of Mathematics of Dibrugarh University jointly organized this 2-day national conference on multidisciplinary approaches on networks and computing. I would like to intimate you that as a part of the Diamond Jubilee celebration, Dibrugarh University has organized up to this day almost 65 numbers of conferences throughout this financial year. These are of international, national, and regional type. And it's actually break earlier records. In the last 5 years, research culture of Dibrugarh University has been developed a lot. Around 2,000 research articles have been published by our faculty members throughout the different Scopus Index journal. This particular national conference is aimed to foster cross-disciplinary research and knowledge exchange among experts and researchers from diverse fields like computer, engineering, computer science, engineering, mathematics, physics, chemistry, statistics, and sociology, and even economics. Multidisciplinary approaches in networks and computing involve integrating knowledge, methods, tools from various fields to tackle complex problems in network design, cybersecurity, data analysis, machine learning, social network analysis, system optimization, etc., and their innovative solution. The cross-disciplinary collaboration is tremendously important to address modern problems that span across traditional boundaries, as for example, using network theory and sociology. Spread of misinformation, viral content can be analyzed. Another very well-known application is addressing cybercrime through collaboration between computer scientists and legal experts. Leveraging AI to improve healthcare delivery, network-based medical system. We are all aware of telemedicine platform. It is developed by integrating AI diagnostics and network communication. In the last 5 years, Dibrugarh University's infrastructure regarding research have been developed a lot. We have implemented huge numbers of projects. I like to inform you that in the February 2023, Dibrugarh University has received DST PARS promotion of university research and scientific excellence of cost almost 11 crores. Under this project, we have installed different high-end equipment and most specifically an HPCC as a central facility. I hope this facility will certainly help to multidisciplinary side of research. So I believe that the conference will provide a platform for experts and researchers from different fields to share their ideas, discuss their findings in the emerging trends, breakthroughs, and future directions. It certainly creates a supportive environment for knowledge sharing, strengthening connection between researchers, experts, and industry professionals to maximize societal impact. So, I hope this conference will be highly beneficial for connecting different branches of sciences to do more fruitful research. with these few words, I formally declare inauguration of these 2-day national conferences. Thank you.
Thank you, Professor Gitika Bora, ma'am. Now I request Professor Surajit Bokataki to share some few words.
Respected chairperson of this organizing committee of this 2-day national conference on multidisciplinary approaches in networks and computing, Professor P.N. Deka, who happens to be our head of the department also, respected Madam Dean Science and Engineering, Professor Gitika Bora Madam, respected Director of DUET, Dr. Mukul Bora, our esteemed guests, the resource persons, my colleagues, dear participants, and my dear friends, students. So, it is indeed a great pleasure for me to be a part, to be associated in the organization of this particular national conference, even though physically I could not spend much time in the organizing part. But whenever there was an issue, Kosi could call me, "Sir, this is happening, what to do?" So if that was within my capacity, I would give him some suggestions like that. So this way, indirectly, I was also part of this particular event. In fact, this is very much relevant for us. This choice of the topics is very much relevant for us, because here we are talking about multidisciplinary approaches, we are talking about networks, we are talking about computing. So it encompasses, it is a confluence of different areas of science where mathematics is somehow connected. So I think this network has a different meaning also. You can say an added meaning. Network has an added meaning where this network is networking all these different branches of science. And if you look at it as a star network, then at the node, at the central node, I think this is mathematics, which is connecting all the different nodes through the spokes of the star network. So that way, it's very relevant, very pertinent. And because we are talking about multidisciplinary, because the university is being awarded the Meru status, that means the multidisciplinary education is research university status last year. So we have also some responsibility to make it happen. And at the same time, this is the recent trend in the world of science, in the world of research, in the world of teaching, that we have to embrace multidisciplinarity. Through under multidisciplinarity, all these different areas are coming up together. I am personally a researcher on multidisciplinary aspects. So my area is game theory, which has networks, which has computational parts, which has economics, which has biology, so many different areas. So that way we are all part of this whole this process. So I think during these next 2 days we have lot of plenary sessions, lot of keynote speakers coming up from different parts of the country, and also some online sessions will be there. Already we have one online session. So I think for the students it would be very much beneficial. And also this is a challenge, this is a new trend, because we have artificial intelligence here. And everywhere nowadays we are facing the challenge of artificial intelligence. Professor Mukul Bora probably will be talking about artificial intelligence in one session. So I think I am looking forward to it, how he is addressing these challenges. So I don't have much to say now. I wish this event a successful one, and also I request all the students to make the maximum use, make the best use of this whole 2-day, all the sessions of this 2-day national conference. So with these few words, I conclude. Thank you very much.
Thank you so much, sir. Sir is the patron of our organizing committee also, and the second recipient of the mail was sir also. So the idea was started in this way also. Sir, thank you so much for your motivational speech. So with this, we are coming to a very good agenda, that is the inauguration of the abstract book copy. And after the inauguration of this inaugural launch of this abstract book, we can distribute to our registered participants, also with our authors. And those who are from abroad, let me tell you another thing. In today's inaugural session, this is actually YouTube live, and I have seen that many viewers are viewing. Even ex-student of our institute, Anna Tamuli, who is also an author, she is now pursuing MS in USA. So with this, I can say that authors are from international recognition also. So may I now request our dignitaries to kindly inaugurate or launch our abstract book copy, and also I would like to request the HODs to kindly come forward so that we can. And I would also request our resource person, Professor Manos Kumar Deka sir and Dr. Bhaskar Deka sir, please come forward.
Thank you, Kaushik sir. Behind every successful event is the dedication and hard work of numerous individuals. To extend our gratitude to all those who have contributed in making this conference a success, I now invite Dr. Niranjan Bora, convener of the National Conference, to deliver the vote of thanks.
Thank you. Respected Dean of Faculty of Science and Engineering, Professor Gitika Bora, Chairperson of the Organizing Committee, Professor P.N. Deka sir, Dean of Students Affairs, Professor Surajit Borokodogi, Director, Duet Dr. Mukul Chanda Bora, participants from the various parts of the country, and teachers from the various centers and departments of Dibrugarh University, and all other stakeholders of Dibrugarh University. I am thankful to the organizing committee for giving me an opportunity to give vote of thanks for this auspicious occasion. First and foremost, I take this opportunity to express my deep sense of gratitude and appreciation to the Honorable Vice Chancellor of Dibrugarh University for his constant support and cooperation for this national conference. We are thankful to the Professor Gitika Bora, the Dean of Faculty of Science and Engineering, for inaugurating the conference with her insightful words. I would like to thank the resource persons from diverse scientific domain for accepting our invitations. Your expertise has truly sparked our intellectual curiosity and will definitely set the perfect tone of exchange of new ideas in the field of network and scientific computing. Moreover, I will also convey my hearty thanks to all the delegates who have joined us for submitting scientific papers from various parts of the country. Your enthusiastic participation and engagement are what truly make this conference meaningful. We look forward to your active involvement in the sessions and discussion over the next 2 days. I am thankful to all the faculty members of Dibrugarh University, research scholars, officers and staff members and all other stakeholders of Dibrugarh University for making the inaugural session a successful one. My sincere thanks goes directly to the State Bank of India as well as the Punjab National Bank for providing financial support to make the conference a successful one. Last not the least, I thank all the members of the organizing committee for their relentless effort for organizing this national conference. Thank you all for making the inaugural session such a memorable one. We are excited for the days ahead and look forward to your fruitful conference. I strongly believe that with your help and support, we can make the conference a remarkable one in the university campus. If you need any assistance, we are always here to help you for the coming 2 days. And with these few words, I'd like to conclude this vote of thanks of this national conference. Thank you.
Thank you, sir. As we conclude the inaugural session, let us all stand in unity and respect. I request everyone to rise for the state anthem followed by the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
With this, we conclude the inaugural ceremony of the National Conference on Multidisciplinary Approaches in Networks and Computing. We hope this event fosters insightful discussions and meaningful collaborations. Thank you all for your participation. Wishing you a productive and enriching conference ahead. Before we forward, we warmly invite our esteemed guests to join us for tea and refreshments. We hope this provides an opportunity for further interaction.
I request all the audience here to please come back in 5 minutes so that we can continue the next session. So next session will be delivered by Director Duet, Dr. Mukul Chandra Bora sir.
এক সেকেন্ড পলিটিকেল মাতি মই একটা মুভ কৰিছো কোনখন
PO's presentation to what should you
আপনি ডেস্কটপ মুভ করব
get it
I request every student to please be seated in this conference.
এসি অফ কৰিব লাগে ন মই ৰবা এক্সটেন্ড কৰি দিছো
Sir, off কৰিব লাগে off
নহয় মোবাইল কৰি চলিছে লাইটটো কেমেৰা ওলাইছে কেমেৰা ওলাইছে লাইটটো বন্ধ কৰি দিব এইটো লাগি আছে এইটো চলি আছে স্ক্ৰীন এইটো আহি আছে এইখন স্ক্ৰীন আহি আছে এইটো স্ক্ৰীন আহি আছে এইটো চাইছো অডিও এইটো চাৰ্টৰ এই চাৰ্টৰ ওচৰত আছিলে ইউটিউব লাইভ হৈ আছে দুটা আহিব লাগিলে কিন্তু হ'লে লাইভটো হৈ আছে পজ কৰি দিছোঁ লাইভটো হৈ আছে পজ কৰি থোৱা আছে
চাহকাপ খাই লওক তোমালোকে চাহকাপ খাই অহা যোৱা কৰক লাগিব নহয় আকৌ এজন এজনকৈ যাবা দুজন নোহোৱা নহয়
মই ভৰাই দিওঁ এইটো কাম নাই ইয়াৰ সেইটো কৈছোঁ ভৰাই দিলোঁ দেই এইটো বেলেগে দিছোঁ এইটো বেছি ভাল আগতে এনেকুৱা আৰু এটা এইটো অলপ বিজয়ী কৰি আছে এতিয়া বেনাৰখন লগাই দিছোঁ চেঞ্জ কৰি দিছোঁ
মিটিঙলৈ দি দিছোঁ
হেৰিত অফ কৰি থৈছোঁ অকল ইয়াত চলি
মিটিংটো উলিয়াচোন আছে আছে চব পাৰিব ঠিক আছে গুগলটো খুলি দিব অ'কে সেইফালে নাই চব বস্তু মিটিং আছে
খোলা আছে ক্ৰম খোলা আছে ন চেট জিপিটি খুলি ৰাখা
অঁ সেইকেইটা খুলি আছে ওচৰত আকৌ যেনিবা ৰৈ থাকিব লাগিব ন চাৰ আপোনাৰ
অঁ নালাগে ৰৈ থাকিব
ৰ'বা এইটো ডাউনলোড কৰি হেৰি PPT প্ৰেজেণ্টেশ্যনৰ হেৰি কৰি দিয়া এইকেইটা PPTখন তুমি এতিয়া ফ্ৰণ্ট পেজটোত উলিয়াই থ'ব পাৰা
স্কেন কৰি
এখন হৈছে
অঁ
মই আপোনাৰ চেট জিপিটিটো কৰি দিছোঁ
ট্ৰাই চেট জিপিটিত যোৱা চলিছে বেছি সৰ্ব নকৰিব আমাৰ ইয়াত ইমান ফাষ্টেষ্ট স্পীড নাই হ'ব এইটো ডিছপ্লে এইটো হ'বতো তাতে অঁ ঠিক আছে এতিয়া সদ্যহতে এইটো কৰি থোৱা এইখন লাইভ কৰিছে
এইখন উলিয়াই থ'লে
এইখন উলিয়াই বাকী তুমি চেট জিপিটি সময়ত কোনোবা এটা আহি যাবা এইখন নহয় কিবৰ্ড কৰিম একো নাই
স্যার টিস্যু আনো নি তাহলে
অলপ দেৰি পিছত ঠাণ্ডাই হ'ব দিয়া ঠাণ্ডা হ'বলৈ দিয়া আকৌ ওচৰত আহিব পাতিবলৈ বিষ্ণু নলাত পাৰ্মিশ্যন নাপালে দুটাই মোক ফোন মাৰিলে অপেন জানুৱাৰীত আমাৰ প্ৰগ্ৰেমটো যিটো আছিলে দুটাই কৈছে যে সিহঁতক পাতিবলৈ দি দিয়ে অথৰিটিয়ে যিটো কয় মই সেইটো শুনিব লাগিব এতিয়া মই কৈছিলোঁ কি প্ৰথম বিচাৰক যে আমাৰ ষ্টুডেণ্টখিনি আপোনালোকৰ প্ৰগ্ৰেমটো চাবলৈ যাব পাৰিব
Welcome everyone. Now I request Dr. Mukul Chandra Bora sir to please come up to the podium and share his few words.
Esteemed faculty members of Dibrugarh University, students, resource person, invited speakers, keynote speakers. So this is just a random thought. So I was not at all prepared, you can say that. But Kaushik asked me that you have to deliver a talk. I said that okay, write it, no issue. Later I thought that I have taken a very big challenge in front of me. But anyway, because the artificial intelligence is coming up in a very big way. Everything will be replaced by artificial intelligence if our human intelligence gets lesser than the AI. So that is the hard truth. Machines were made to replace manual labors, but now we are become slave of machines. Whenever we go to any places, anywhere, we used to take the help of the Google. What is Google? Google is some sort of web portal or some sort of web-based applications wherein we get all the information from Google only. And we never check whether it is correct or not. That is also one of the points. So vital point of NEP 2020 is the integration of use and integration of technology in education. So 90% people believe that the PPT and all those slideshow and video, all those things belongs to those categories. No, it is beyond that category. What is that beyond category? That is the category called as AI and robotics. So I was fortunate that I could have interacted with all those dignitaries, whoever has prepared the NEP 2020. I was in the first meeting with Dr. K. Kostirangan when I worked in the Ministry of Education. So that is why I see something extra. So whatever UGC guidelines has come for the faculty recruitment and teachers, that I have perceived before 1 year. I said that these things will not be there in near future. I don't know how I can speak because I had a long interaction with those persons. So there will be many more things will come which will behave like a coronavirus for we all people. You can say that it is a coronavirus. That means who will die and who will not die, that we cannot ascertain. The day may come when there will be a contract basis or tenure track faculty member which is there in the foreign countries, but that will be also maybe there in our own place of working. That means if your immunity is good, immunity means intellectual capability, if your creativity is good, if your thinking ability is beyond artificial intelligence, then only we can survive. Otherwise this is difficult for us to survive. So my next slide, what go to keyboard code. So these are the three pillars of national education policy, according to my own assumptions and my understanding. The first one is Indian knowledge system. Second one is multidisciplinary research and education. And third one is the use of disruptive technologies like ML, AI, IoT, etc. I write ML before because AI is a product of machine learning. AI is a product of machine learning. Anyway, so these three pillars can be resembled to the Hindu deity called as Brahma, Vishnu and Rudra. What is Brahma? He is the creator. What is creator? That is the Indian knowledge system. That is our fundamental. What is Vishnu? Vishnu means he used to take care of everything. It includes that one you call as environmental science also. That is called multidisciplinary research. That means Vishnu takes care of all the creations. It may be human being, or it may be animals, or it may be grass, it may be plants, anything else. We believe that Vishnu takes care of everything. And third is a Rudra. Rudra means there will be destruction in the academic sector. How it will destroy? It will destroy through the process of artificial intelligence. ChatGPT खोला. So you have seen this ChatGPT. So any technology which come first to the knowledge of myself, I used to try. So I am from geotechnical engineering. I write simply. Right. Fundamentals of soil mechanics. So let us see. Please see how much it has informed. Everything. Things are still coming. Students, have you observed it? Especially the students, have you observed it or not? You see, still it is giving the information. So if I want to survive as a teacher of geotechnical engineering, so I have to know beyond chat AI. That is why I am calling it as a corona virus. That means if my immunity is strong, then I will be survived. Otherwise, it will be difficult for me to survive in the age of artificial intelligence. You see how much it has given. It has given almost all the books and everything. Anything you can write here. Like say, what is machine learning? So am I right or wrong? If everything gives by the computers or AI, then we have to make our relevance, na? How to make our relevance? Because we have to be very much having the strong immunity. That means we should have creativity, intellectual capability, everything. Otherwise, no. This is very hard to accept, but we have to accept. ইমানখিনি যে ষ্টুডেণ্ট এটা যদি ঘৰতে পাই যায় সি ক্লাছত আহিব জানো আপুনি মই কি পঢ়াম ইয়াৰ বিয়ণ্ডত পঢ়াব লাগিব না ইয়াৰ বিয়ণ্ডত পঢ়োঁতে মই মোৰ ভাষাত কৈছোঁ যে ডেট ইজ কল্ড গুড ইমিউনিটি এতিয়া আমাৰ সময় আহি গ'ল যে আমি তাৰ বিয়ণ্ডত ভাবিব লাগিব ইফ ইউ কেনট থিংক বিয়ণ্ড ইট চ' নাৱেডেজ এভৰিবডি হেজ গট দ্য এণ্ড্ৰইড ফোন ইট ইজ ভেৰি চিপ এণ্ড ইউজাৰ ফ্ৰেণ্ডলি. So you can have everything on your fingertips. So let us go to that one. I could go little PPT. So that is why I have put it like this. Brahma, Vishnu and Rudra. What is the next step? Let us talk something about artificial intelligence. And I have written something, some keywords I have given to the ChatGPT. It is not like that I have not tried. I have tried a lot. I am trying ChatGPT since its origination. So I have given the keywords. This is the keyword. Please make a paragraph. It makes a paragraph. Then where is our place? We have to go to beyond AI. Then only our place will be there. And days are not far when there will be robots standing in front of us and it will deliver everything. So that is called technology use and integration. The Terminator was the first film where AI has been heavily used. Nowadays the films are made with 100% AI assistance. Few shots were taken, then everything has been created through the AI. So these are the three categories of AI so far present condition is concerned. What to do then? Application of AI is everywhere. AI in healthcare, we know the robotic surgery is coming to picture because human beings has got some sort of emotions and something else. Some doctors are in the operation theater, so he got a call that your mother is seriously ill, so there should be some error in the surgical operations. So that is why healthcare is adopting those artificial intelligence and robotic surgery is coming to picture. Then it is finance, that is fraud detection, stock market prediction, automated trading, those are also there. Education, personal learning, AI tutors, automated grading. Things are there. And I have got some information that students' performance evaluation and question paper setting is also done through the AI model. If everything we believe on AI, then what will happen to us? So, if everything we dedicated to AI, then what will happen to us? We will be nowhere. Am I right or wrong? Please tell me. If we say everything will be managed by artificial intelligence, then where is our intelligence? So our intelligence must be there because AI itself is made by human intelligence. But you should be or we should be more intelligent than the input intelligence given to the robots or the AI. So AI in education will make huge transformation in teaching learning process of future. That will make personalized learning possible because students may go home and they can go through the AI platform and they can use it. And now it is almost free and it will be more user friendly in near future. Intelligent tutoring system, number 3 automated grading and assessment, AI chatbots and student support, so on and so forth. Can AI replace human beings? No. But AI can only replace because when we become the slave of AI. ঘৰ কাম কৰা চাকৰে কেতিয়া মালিকৰ ওপৰত অভাৰ পৰা হয় যেতিয়া আপুনি চাকৰ ওপৰত বেছি ডিপেন্ড হৈ যায় এইবিলাক মেচিনছ আৰ ইন ইঞ্জিনিয়াৰিং লেংগুৱেজ উই কল মেচিনছ আৰ দ্য স্লেভ অফ হিউমেন বিংছ আমি ধান বানিব অসুবিধা ডেট ইজ ৱাই ৰাইচ মিল আমি আটা পিচিবলৈ অসুবিধা ডেট ইজ ৱাই ফ্লোৰ মিলছ okay we need some devices to make the human labor more comfortable and user friendly. So these are the basic difference between human and AI intelligence. And we have to keep in our mind, every time we have to keep in our mind, AI means not me, AI means it is my slave. So we should not make slaves are overpowered to me. That is called machine. If we become slave, then machine will overpower us. Now it is happening everywhere. Machines are overpowering everybody. So these are the basic difference. What we have human intelligence that is called as innovative, think and creativity. AI don't have any creativity. AI jiman input di thom memory himane hi ko pa. But tar beyond that hi kobo, he cannot speak beyond that intelligence. So if we take everything into order, that means 3 phases. That Brahma, Vishnu, Rudra, that means Indian knowledge system, multidisciplinary research and the things which are known as 21st century technology, then we will get a Saityam Shivam Sundaram environment of the NEP 2020. So this is the fundamental concept when the AI will integrate in education. Now, the first of all, AI will replace the faculty members of the private institutions specially because those are managed by a trust. So trust will see if I have to pay 7 lakhs to a faculty per year and if we can replace 5 faculties, so 35 lakhs, if robot is available, definitely they will put the robot in order. They will not go for those human intelligence at all because it is already available in the AI chat box and everywhere. So that is what I have told that I will speak on this issue, but this is the high time that we should think beyond AI. Then only it will be good for us. Otherwise, it will be good for us. Those who don't have the immunity system strong, they have died in coronavirus. This is just like a coronavirus is coming into picture in education sector. With this much of word, I think I have spoken enough. I am not making anybody discomfort, but I am telling you the truth. You believe it today or not, it will come and it will overpower us if we do not make our intelligence stronger than the artificial intelligence. সঁচা কথা সহ্য কৰিবলৈ বহুত টান লাগে, কিন্তু সঁচা কথাই সহ্য কৰিব লাগিব, কাৰণ then only you will become ready for the future. So with this much of word, I thank the organizer for giving me the opportunity to speak on this occasion. So this is all from us. If you have got any query or any questions, you can ask me. If no, then I can stop here. Thank you very much.
Any queries?
শিৱ মানে ডিষ্ট্ৰাকটিভ টেকন'লজিজ। এতিয়া আমাৰ যেনেকৈ হ'ব, কাইলৈ এটা ৰবটে মোক ৰিপ্লেচ কৰি বহি থাকিব, এটা কথা কৈ থাকিব, গতিকে এইটো সংহাৰ তাৰমানে। দিছ ইজ দ্য ডিষ্ট্ৰাকশ্যন অফ দ্য প্ৰেজেণ্ট এডুকেশ্যন ছিষ্টেম এণ্ড গোয়িং টু দ্য নিউ এডুকেশ্যন ছিষ্টেম। সেই কথাটো মই সেইকাৰণে ৰুদ্ৰ বুলি কৈছোঁ। এইখন শ্লাইড মই ভূপালত বনাইছিলোঁ, মই ইয়াৰ পৰা যাওঁতে বনোৱা নাছিলোঁ, তাত মনত কৰি বনালোঁ। এভৰিবডি লাইকছ ইট এণ্ড দে লাইক ইট ভেৰি মাছ, যে ইট ইজ কোৱাইট ৰিজেম্বল টু দেট ব্ৰহ্মা বিষ্ণু এণ্ড ৰুদ্ৰ। আপুনি এই কথাটো ছাৰ বুজি পাইছে? এতিয়া কথাটো ক্লিয়াৰ হৈছে? ঠিক কওক। নহয়, মই সেইটো চেঞ্চত কোৱা নাই। মই একচুৱেলি আই এম নট টকিং এবাউট ডেট চেঞ্চ। নাই নাই, মই আপোনাৰ পজিটিভিকৰ কথা কোৱা নাই। মই কৈছোঁ যে ব্ৰহ্মা মানে ক্ৰিয়েটৰ মানে অৰিজিন অফ নলেজ ইন এনচিয়েণ্ট ইণ্ডিয়া, ডেট ইজ IKS। বিষ্ণু মানে হৈছে টেকিং কেয়াৰ অফ অল দ্য চেক্টৰ্ছ, ডেট ইজ মাল্টিডিচিপ্লিনাৰী ৰিচাৰ্চ, এণ্ড দিছ ইজ কল্ড এপ্লিকেশ্যন অফ ডিষ্ট্ৰাকটিভ টেকন'লজিজ ইন এডুকেশ্যন। আপুনি কওক এতিয়া। অঁ নাই, মই সেই চেঞ্চত কোৱাই নাই। মই কৈছোঁ যে কথাটো বেলেগ এটা চেঞ্চত মই সেইটো হ'বই, সেইটো ঘটিবই। নাই নাই, তাৰপিছত আপোনাৰ ক্ৰিয়েশ্যনো হ'ব। মই সেইকাৰণে ক'লোঁ ডিষ্ট্ৰাকশ্যন যে ক্ৰিয়েশ্যন হ'ব। ক্ৰিয়েশ্যনত সেইবিলাক সোমাব 21st century স্কিল, মেচিন লাৰ্ণিং, AI, IoT, ভাৰ্চুৱেল ৰিয়েলিটি। আজিৰ পৰা 4-5 বছৰ আগতে আপোনালোকেও টিভিত দেখিছিলে, কোনোবা মিডিয়া চেণ্টাৰত দেখাইছিলে, এটা ভাৰ্চুৱেল মানুহ আহি পেলাই টিভি নিউজ পঢ়ি থাকে। আমি দেখিছিলোঁ এইবিলাক। জি টিভিতে প্ৰথম আৰম্ভ কৰিছিলে, নে আজতকে আৰম্ভ কৰিছিলে, কোনোবাই আৰম্ভ কৰিছিলে। এতিয়া সেইটোও হ'ব। 2 দিনৰ পিছত ষ্টেনফৰ্ড ইউনিভাৰ্চিটি প্ৰফেচাৰ চিম্পলি ষ্টেণ্ডিং ইন ফ্ৰণ্ট অফ আছ ইন এ ভাৰ্চুৱেল প্লেটফৰ্ম। কণ্টেষ্ট প্ৰচেছ, এইটো হৈ থাকিব, এইটো হৈ থাকিব। আমাক অভাৰ পাৱাৰ কৰি দিব অঁ নহয় মই সেইটো কথা কোৱাই নাই মই কৈছোঁ যে আপুনি কোৱা কথাটো 100% কাৰেক্ট আপুনি কৈছে যে তাত কি ইনফৰ্মেশ্যন বা কি ইনপুট দিয়া আছে সেইটো এটা মেটাৰ কৰে মই কোৱা যে AI কোৱা সকলো বস্তু শুদ্ধ কিন্তু মই এইটো বস্তু নিজেই এক্সপেৰিমেণ্ট কৰি দেখা পাইছোঁ যে AI মোটামুটি আপোনাক 70% কাৰেক্ট আনচাৰ দিয়ে নহয় মই মোৰ যিটো নলেজ তাৰপৰা কৈছোঁ কাৰণ মই ইউজ কৰোঁ আই ইউজ হেভিলি AI আপুনি বিশ্বাস নকৰিব পাৰ্চিয়ান ভাষা লিখা কিতাপ পঢ়োঁ মই AI দি পেলাই ঠিক আছে একো নাই মই বেয়া নাপাওঁ নাই মোৰ ফেকাল্টি জানেতো
I am okay. ব্ৰহ্মা আৰু মানে শিৱই সোনকালেই মানে হেৰিবিলাক দিয়ে বৰদানবিলাক দি দিয়ে আৰু যেতিয়াই প্ৰব্লেম হ'ব তেতিয়াই বিষ্ণুৱে
Sorry for the minor inconvenience, everyone. Now I request Dr. Nomi Borua ma'am to please come up to the podium.
Thank you. A very good afternoon to all of you, especially the session before the lunch, right? Respected Dean Student Affairs, Professor Surojit Borkotaki sir, dear invited speakers, Professor Manoj Kumar Deka, Professor Bhaskar Deka, dear authors of the various paper presentation which would be coming up. Thank you organizing committee for inviting me for this plenary talk. So today I am going to present on the topic POS tagging and its importance in computational linguistics for SMEs. So I won't be going in depth to the technical thing. So very common thing which all of us use and currently using in our day-to-day life. Okay. So, POS. What is this POS actually? The abbreviated form of it is an abbreviated form, and it means part of speech. So, whenever you go to school during your early days, right? All of you went to school and came to this higher education institution. So, POS, it is being taught to us, but when I am speaking here, you are thinking it will be something different thing. No, it's not. But it is something related the way it is taught to us in our English grammar. And the same thing we also need to teach to the computer in order to avoid all the confusions and what previously in the previous session our director sir had mentioned about it may rule us or it may not rule us. The question came out, right? But I will say it will not rule us. A very small example, I just gave that example to my students, to my MTech students as well as to my BTech students also a few days back, and you can see no doubt they are working on, but still, in fact, how much they say Google also they make confusion. Just want to show something. Just okay, all of us use this one, Google Translate. In order to, just sir told that he used the Persian script to understand. So now, here we can translate. So, I will write in English and I will go to Hindi, okay, because Hindi is known to all of us. Already the students, my students to whom I had already spoken to, they already know, but it is to those who had been new to this topic. Google is awesome. A few days back, I gave this example to my students to BTech 6th semester and MTech 2nd semester. And what was the translation that time? During that time, actually we gave this feedback actually when now it is Google is Kamal hai, but a few days back it was Google Adbhut hai. And like almost 50 to 60 students had experienced this translation, right? So, what, and Professor Deka also, he told that about LLM. So we are making it means we are giving them training again and again, but still somewhere they lag. And how they lag and how it is related to POS, all that I will be speaking today. So POS, so parts of speech. School তোমালোকে সবেই পঢ়িছিলা ইংলিছ গ্ৰামাৰ তোমালোকক প্ৰথমতে সদায় তোমালোকক কয় নাউন কি হয় হোৱাট ইজ নাউন তোমালোকে মুখস্থ কৰা তোমাকে চাগে ডেফিনেশ্যনটো সবেই জানা হোৱাট ইজ নাউন এ নাউন ইজ এ নেমিং ৱৰ্ড এইটোতো সবেই পঢ়া এ নাউন ইজ এ নেমিং ৱৰ্ড ৰাইট so these are the POS of the English grammar which we studied তাৰপাছতে আমি ইংলিছ ভাষাটো গম পাইছোঁ প্ৰথমেতো আমাৰ ABCD শিকাইছিলে হয়নে নহয় তাৰপাছত আমাৰ ABCD শিকালে তাৰপাছত আমাক পাৰ্টস অফ স্পীচ না এইটো ভাৰ্ব বুলি কয় কাৰণ ই একশ্যন হয় এইটো এডজেক্টিভ বুলি কয় কাৰণ ই কালাৰ বা ভাল লগা বেয়া বিউটিফুল কিবা এটা কালাৰ য়েল্লো পিংক এনেকুৱা ধৰণৰ বিভিন্ন ধৰণৰ পাৰ্টস অফ স্পীচ আছে ৰাইট Similarly, তোমালোকক এতিয়া সৰুৰ পৰা যেনিবা তোমালোকৰ ঘৰত এগৰাকী মানুহ আহে, তোমালোকৰ ঘৰত শিকায় যে এয়া তোমালোকৰ আমুক পেহী হয়। সেই মানুহগৰাকীক তোমালোকৰ দেউতাই কয় পেহীক মাতিলি নাই, মায়ে কয় পেহীক মাতিলি নাই, আইতাই কয় পেহীক মাতিলি নাই। তোমালোকে সেই মানুহজনী তোমালোকৰ হিউমেন কম্পিউটাৰটো তোমালোকৰ অলৰেডি ৰেকৰ্ড হৈ গ'ল যে এই মানুহগৰাকী আমুক পেহীয়ে হয়। ট্ৰেইন কৰিলে নাই তোমালোকৰ সৰুৰ পৰা? তোমালোকক ট্ৰেইন আমুক পেহী যে আমি জেনেৰেলি আমাৰ অসমীয়াত মানে কি হয় ভনী পেহী, এইটো মানে খুব এটা কমন নাম হয়, মানে ভনী মানে ভণ্টি হয়, ভনী মানে ভনী পেহী, ভনী মাহী, ভাইটি মামা, এনেকুৱাবোৰ আমাৰ খুব ট্ৰেইণ্ড হয় মানে। তো সেইটো একচুৱেলি আমাক ট্ৰেইণ্ডহে কৰিলে। কিন্তু আজিকালি তুমি চাবাচোন খুব এই ভাইটি মামা, ভনী পেহী এনেকুৱাবোৰ নোহোৱা হৈ গৈছে, হয়নে নহয়? এতিয়া এইটোতো আমাক সৰুৰ পৰা ট্ৰেইন কৰিলে, ঠিক তেনেকৈ কম্পিউটাৰটোকো ট্ৰেইন কৰিব লাগিব। আৰু কম্পিউটাৰটোক যদি আমি ট্ৰেইন নকৰোঁ, যদি কম্পিউটাৰ উল্টা পুল্টা কয়। এটাতো মই এতিয়া তোমালোকে কেইজনমান ষ্টুডেণ্ট অলৰেডি ইয়াত প্ৰেজেণ্টে আছা, যোনটো তোমালোকে গুগল ইজ অছম, তোমালোকে অদ্ভুত বুলি নিজেই তোমালোকৰ ক্লাছত মই তোমালোকক কৰিব দিছিলোঁ প্ৰেক্টিকেলটো, আৰু কিন্তু আজি চোৱা ইট হেজ বিন আপগ্ৰেডেড। ঠিক তেনেকুৱা এটা এক্সাম্পল, ফাইন, আৰ ইউ ফাইন? এইটো এতিয়া নহয়, আজি পৰা 2-3 বছৰ আগৰ এটা মানে মোৰ ষ্টুডেণ্টে কৰিছিলে, তাহাঁতি কৰোঁতে এনেকুৱা এটা ডিফেক্ট পাইছিল, আৰ ইউ ফাইন? যেতিয়া ট্ৰান্সলেট কৰিছোঁ, মই এইটো এক্সাম্পল ক্লাছতো দিছিলোঁ আগতে, আৰ ইউ ফাইন? তেতিয়া তাত মানে ফাইন মানে কি, তোমাৰ ভালনেহে, তোমাৰ ভালনে, এইটোহে হয়। তাত আহিছে তোমাৰ জৰিমনা, ফাইন মানে ফাইন লগাই দিলে, ফাইন, বুজি পালা? ফাইন লগাই দিলে মানে। চ' এই পাৰ্টছ অফ স্পীচৰ কিয় ইম্পৰ্টেঞ্চ, আকৌ এতিয়া মই আৰু এটা এক্সাম্পল ক'ম তোমালোকৰ ইংলিছত। ঘড়ী চবেই পিন্ধা, ৱাটচ, চবেই ৱাটচ ইউজ কৰা। এই ৱাটচটো কি হয়, কি পাৰ্টছ অফ স্পীচত পৰে? নাউন। মই তোমালোকক এইটো মানে জানা নাজানা সোধা নাই, জাষ্ট ইন জেনেৰেল সুধিছোঁ। ৱাটচ মানে কি হয়? এইটো আমাৰ ঘড়ী, যোনটো আমি সময় চাওঁ। ৱাটচ মানে কি হয়? আই এম ৱাটচিং এ মুভি, সেইটোতো ৱাটচ হয়। সেইটো কোনটো পাৰ্টছ অফ স্পীচ? কিন্তু সেইটো যদি কম্পিউটাৰটোক যদি ভালকৈ তোমালোকে নুবুজোৱা, ট্ৰেইনিং নিদিয়া, আগৰ শব্দটোৰ লগত পাছৰ শব্দটোৰ লগত, তেতিয়া কিন্তু সি আকৌ খেলি মেলি কৰিব, বুজি পাইছা? কিন্তু কি হয়, আমাৰ আকৌ যোনবোৰ আমি কওঁ মানে এতিয়া যেতিয়া মই আছামিজ লেংগুৱেজ স্পেচিফিকেলি লৈছোঁ এইকাৰণে, কাৰণ আমি চবেই মেক্সিমাম ইয়াত থকা পপুলেশ্যনটোৱে আমি অসমীয়া কথা কওঁ, বা আমি জানো অসমীয়াটো, এটলিষ্ট অৰেলি আমি জানো। আমাৰ কি হয়, এটা ৱৰ্ড যেনিবা ছোৱালী, এই ৱৰ্ড ছোৱালী বুলি আমি কিবা এটা ক'লে তাই মোৰ ছোৱালী হয়, ছোৱালী হয়। এই ছোৱালীবোৰে ইমান হাল্লা কৰিছে, ছোৱালীবোৰে। তাৰপিছত খং উঠি আহিছে কোনোবা, এই ছোৱালী গালে যে এনেকুৱা কথা কিছুমান পাতিছে, মাথাটো নষ্ট হৈ গৈছে। ছোৱালী গালে দেই, ছোৱালী গালে, ছোৱালীবোৰে, ছোৱালীজনীয়ে, এই যে পাছত যে কিবা জনীয়ে গালে বোলে কিবা কিবি যে লাগিছে, কম্পিউটাৰে আকৌ আমি মানুহৰ ব্ৰেইনটোহে সেইটো কেটচ কৰে, কম্পিউটাৰে কিন্তু চবকে বেলেগ বেলেগ শব্দ বুলি ভাবে, ঠিক আছে? যেতিয়াই বেলেগ বেলেগ সেই শব্দ বুলি ভাবে, তেতিয়া কি হয়, তাৰ পাৰ্টছ অফ স্পীচটো আকৌ বেলেগ বেলেগ কৰি দিয়ে। পাৰ্টছ অফ স্পীচটো বেলেগ বেলেগ কৰি দিয়াৰ লগে লগে তাৰ মিনিংবোৰো বেলেগ বেলেগ হৈ যায়, হয়নে? একশ্যন আৰু নাউন, এই দুটা বস্তু বেলেগ বেলেগ হয়। আৰু এটা এক্সাম্পল দিম, যেতিয়া মই ফাৰ্ষ্ট এই পাৰ্টিকুলাৰ এৰিয়াটোৰ ৰিচাৰ্চ, মষ্ট প্ৰবেবলি প্ৰফেচৰ ডেকা আৰু ডক্টৰ ডেকা দুইজনে, যিহেতু আমাৰ মানে উই আৰ ষ্ট্ৰীম লাইন টু ওৱান ছেইম আমব্ৰেলা, তেওঁলোকে চাগে এক্সাম্পলটো অলৰেডি জানিব পাৰে। যেতিয়া মই ফাৰ্ষ্ট মানে গৈছোঁ এইটো টপিকত, মানে এটা ৰিলেটেড টপিক এটা কথা পাতিবলৈ, মোৰ ছাৰ এজনে এক্সাম্পল দিছে, মানে মোক পাৰ্টছ অফ স্পীচটো উলিয়াবলৈ কৈছে, একচুৱেলি মোক এক্সাম্পলটো দিছে, আৰু তুমি কোৱা এনেকৈ কৈছে, গগনে গগন ফালি মাতিলে, এতিয়া কি কৰা, কোন গগন ফালি মাতিলে, গগনে গগন ফালি মাতিলে। সেই প্ৰথম গগনটোতো বুজি পাইছোঁ, ই গগন তাৰ নাম হয়। ছেকেণ্ড গগনটোতো সি নাম নহয়, কম্পিউটাৰটোৰ খেলি মেলি লাগি গৈছে নহয়, গগন বুজি পাইছা? সো সেইকাৰণে এই পাৰ্টছ অফ স্পীচটো মানে ইমান ইম্পৰ্টেণ্ট হয় যিমান তোমালোকে চেট বক্সত ইট মে বি টেক্সট ইট মে বি স্পীচ অ'কে এনেকুৱা নহয় যে অকল লিখাটো কথাই আমি কৈছোঁ বা মানে যিকোনো লেংগুৱেজ এটা কি বস্তু লেংগুৱেজ কি হয় লেংগুৱেজ ছামথিং উই কমিউনিকেট আমি কমিউনিকেশ্যনৰ কাৰণে এতিয়া মই যে ইংলিছটো কৈছোঁ তোমাকে ইংলিছ জনাৰ কাৰণেহে বুজি পাইছা ইংলিছ যদি নজনা হ'ল তেন্তে বুজি নাপালাহেঁতেন বা নাপালেহেঁতেন হয়নে নহয় ঠিক তেনেকৈ কম্পিউটাৰো বুজি পাব লাগিব আমাৰ কথাখিনি তেতিয়াহে সি শুদ্ধকৈ ইণ্টাৰপ্ৰিট কৰিব কৰেক্টলি চ' তাৰ কাৰণে দ্য ফাৰ্ষ্ট থিং যেনেকৈ আমাৰ স্কুলত আমাক ইংলিছ গ্ৰামাৰ বুলি স্পেচিফিকেলি ছাবজেক্ট এটা দিছিলে ঠিক তেনেকৈ তুমি যিমানে ৰবটিক্স AI যিয়ে তোমালোকে কৰা আজিকালিতো চব নিজৰ নিজৰ লেংগুৱেজতে চব আহি গৈছে হয় নহয় আমি আজিকালি আগতে ধৰা ইংলিছ লিখোঁ আজিকালি আমি বেলেগ বেলেগ ভাষাটো লিখোঁ কাৰোবাক কমেণ্ট কৰোঁ অকল সেইটোৱে নহয় আজিকালি আমি ইম'জি থ্ৰু দিও কমেণ্ট কৰোঁ কাৰোবাৰ ওপৰত খং উঠিছে একদম খং উঠা এটা ইম'জি দি দিওঁ এইটো কমিউনিকেশ্যনে হয় ৰাইট চ' সেইটো অকণমান বেলেগ এটা লেভেলত আমি বেছটোলৈ যাওঁ চ' পাৰ্টছ অফ স্পীচ টেগিং চ' যেনেকৈ আমাক স্কুলত আগতে আমাক শিকাইছিলে যে পাৰ্টছ অফ স্পীচ ঠিক তেনেকৈ কম্পিউটাৰকো শিকাব লাগিব তোমালোকে যিয়ে চেট বক্স চেট GPT যিয়ে ইউজ কৰা লাগিলে বেছটো কিন্তু ই আছে ইয়াক নহ'লে তোমালোকে একো আগবাঢ়িব নোৱাৰা যিমান AI চেট GPT যিয়ে কথা কোৱা লাগিলে ঠিক আছে চ' হিয়াৰ দ্য লাষ্ট পইণ্ট book is a noun and another I booked my ticket it's a verb so importance in NLP so মই আগতে এটা wordটো ইউজ কৰিছিলোঁ computational linguistics or similar name NLP means natural language processing so the processing of the natural language মানে যোনবোৰ language human beings use in day-to-day life to communicate each other there are so many natural languages in this world right so why it is important for the linguistic analysis এতিয়া তোমালোকক মই আৰু এটা এক্সাম্পল দিম এই লিংগুইষ্টিক এনালাইচিছটোৰ ওপৰত এটা বেছ কৰি মই এটা এক্সাম্পল দিম ইংলিছত যেনিবা I eat rice it is subject eat it's a verb rice it is an object I eat rice হে একেটা বস্তুৱে যদি মই অসমীয়াত কওঁ মই ভাত খালোঁ মই এইটো সাবজেক্ট হয় ভাত it's an object খালোঁ then verb চোৱা ইংলিছ আৰু অসমীয়া যোনটো এতিয়া মই কৈ আছোঁ আছামিজ ষ্ট্ৰাকচাৰটো হৈছে লেংগুৱেজবোৰ ষ্ট্ৰাকচাৰ থাকে যেতিয়া তোমালোকে লেংগুৱেজবোৰ ষ্ট্ৰাকচাৰবোৰ কম্পিউটাৰক বুজাবা তেতিয়াহে কম্পিউটাৰে কাৰেক্টলি ঠিক হয় মানে বেছ কথাবোৰ কম্পিউটাৰক খুব ভালকৈ শিকাব লাগিব নহ'লে খুব খেলি মেলি কৰে চ' যোনটো মই ক'লোঁ I eat rice it is a SVO structure বুলি কয় মই ভাত খালোঁ এইটো হৈছে SOV structure তেনেকৈ আৰু বেলেগ বেলেগ ষ্ট্ৰাকচাৰো আছে OVS structure OSV সেনেকুৱা total 6 different structures are available in the languages prevailing in this world ছটা languages specifically মানে কৰিছে কিন্তু SOV SVO OVS এইকেইটাতে maximum language আছে বাকীখিনি খুব কম language আছে ঠিক আছে মেচিন ট্ৰান্সলেশ্যন আমি আমাৰ আজিকালি মেচিন অলপ আগত ছাৰে ক'লে যে পাৰ্চিয়ান স্ক্ৰিপ্টৰ পৰা মই লৈ পঢ়িছোঁ চ' সেইটো এটা মেচিন ট্ৰান্সলেশ্যন আছে কাৰণে আমি বেলেগ বেলেগ ধৰণৰ লেংগুৱেজবোৰত গ্ৰিপিং আহিছে এই মেচিন ট্ৰান্সলেশ্যনটো এটা খুব মানে এটা ইম্পৰ্টেণ্ট এনেকুৱা হয় তোমালোকে সকলোৱে জানা যে ৰাছিয়া আৰু USA এটাত মানে ৱৰ্ল্ডৰ মানে এটা বিগ পাৱাৰ বুলি আমি ভাবোঁ কি হ'ল ৰাছিয়া একচুৱেলি টেকন'লজিত মানে বহুত আগবঢ়া আছিলে বাট ৰাছিয়ান মানুহবোৰে ইংলিছ ইমান ভালকৈ নাজানে চ' most of their books are written in Russian language তাহাঁতৰ ৰাছিয়ান ভাষাত কিতাপবোৰ বেছিকৈ লিখা আছিলে তো যিহেতু ৰাছিয়ান ভাষাত আমি নাজানো চ' সেইকাৰণে কি লিখা আছে আমি গম নাপাওঁ ৰাইট তাৰপাছত কি হ'ল the US কিটা তাহাঁতিতো মানে তাহাঁতি যিহেতু দুটা মানে অপজিট পাৰ্টি বুলিয়ে ক'ম মই যিহেতু আমি ইন জেনেৰেল ভাষাত তাতে সদায় কম্পিটিশ্যন কোন আগত যাব পাৰে তাৰপিছত কি হ'ল ৰাছিয়ান ভাষাতহে ৰাছিয়ান কিতাপবোৰ লিখা আছে আৰু টেকন'লজিকেল তাহাঁতি আগবঢ়া হয় বাট কিন্তু পৃথিৱী কোনে এইটো ইউটিলাইজ কৰিব পৰা নাই তাৰপিছত কি কৰিলে আমেৰিকানছবিলাকে কিছুমান ৰাছিয়ান কিছুমানক পইচা দি সৰহকৈ পইচা দি মাতি আনিলে চব ৰাছিয়ান বুকবোৰ ট্ৰান্সলেট কৰিলে ইংলিছত আৰু তাৰপিছত কপিৰাইট কৰিলে এইবোৰ আমাৰ হয় বুলি এইটো এটা ৰিয়েল ফেক্ট হয় ঠিক আছে চ' দিছ মেচিন ট্ৰান্সলেশ্যন এতিয়া সেইকাৰণে আগৰ নিচিনাকৈ এই কামটো এতিয়া কৰিব নোৱাৰে আৰু বুজিলা তো ইনফৰ্মেশ্যন ৰিট্ৰিভেল সেইটো কাৰণে ইনফৰ্মেশ্যনছবোৰ প্ৰপাৰ পাৰ্টছ অফ স্পীচ ডিটেইলছটো খুব ইম্পৰ্টেণ্ট হয় আৰু যেনেকৈ অলপ আগত আমি হ'ল যে ঢেৰ ডাঙৰ টেক্সট এটা যোনটো আমাৰ বহুত দিন লাগে কিন্তু সেইটো কম সময়তে আমি টেক্সট চামাৰাইজেশ্যন থ্ৰুদি আমি গম পাব পাৰোঁ উই কেন ন' ইট বহুত ডাঙৰ টেক্সট ইট ইজ অফ 10,000 words but we want to know the gist so it is text summarization you want 10% of the total article it will be given 20% accordingly okay so there are various applications I won't be going in details so coming to the language Assamese so it is one of the Indo-Aryan language which is very rich in its morphological systems inflection মই যে অলপ আগতে ক'লোঁ ছোৱালীজনীয়ে ছোৱালীবোৰে ছোৱালীখিনিয়ে ঢেৰ এনেকৈ বেলেগ বেলেগ আমি যে কৰোঁ ইনফ্লেকশ্যন এটা ৱৰ্ডৰে বেলেগ ঢেৰ মানে ভেৰাইটিজ মানে তাৰ ডিৰাইভেশ্যন আছে নেক্সট some nouns are there multiple pronoun reflecting person he বুলি কোৱাৰ লগে ল'ৰা নে ছোৱালী আমি ধৰিব নোৱাৰোঁ no doubt in text he মানে ল'ৰাই হয় masculine but when we speak if you go to different districts and see their dialogues from that he you cannot identify whether it's a boy or it's a girl he and you can see that many aged people used to use this term he not tai but he all are he and in fact after coming to Dibrugarh also I had seen one more difference is that for a girl ছোৱালী এজনী কি কমে ছোৱালী কওঁ হয় নাই কিন্তু তুমি if you go to nearby villages you can see this word ল'ৰাজনীয়ে but it's a girl not the boy but it's very difficult for the because আমিতো oral যদি তোমালোকে যদি স্পিচ হিচাপে যদি কোৱা তে ল'ৰাজনীয়েতো কোনো এনেকুৱা ডিক্সনেৰীত নাই আমাৰ যোনটো মানে আমাৰ যোনটো ষ্টেণ্ডাৰ্ড অসমীয়া অভিধান মানে যোনখন ডিক্সনেৰী যোনখন কথা কয় তো সেনেকুৱা ধৰণৰ আমাৰ কোনো নাই চ' এইবোৰটোতো চলিত ভাষা হয় বা চলিত মানে হয়তো কোনোবাই এটা মেছেজত লিখিব পাৰে কোনোবাই হয়তো চেট জিপিটি কিবা এটা দিওঁতে ৱৰ্ডটো লিখিব পাৰে তো কম্পিউটাৰ কনফিউজে হৈ যাব বাট ষ্টিল কম্পিউটাৰ কেনট অভাৰকাম হিউমেন এইটো কেতিয়াও নহয় চ' টেইলাৰ text set with respect to Assamese in Assamese you can see here there are some text set yet ami dekhisu je teo enaka kisan text set kisuman ase so in order to make the computer POS tagging ami Assamese language or duta dhornor text set use koru eta hoise see let me details at yes there are two text sets available for use in Assamese jodi okhomia jetu ami ebur digital kora jimo kaam koru computer bujabole ami duta standard text set amar Assamese language use koru for English there are various standard text sets are available coming to only specific to Assamese language one is the BIS text set BI stands for Bureau of Indian Standard and this text set it is a recent one compared to the previous one LDCIL Assamese text set but the advantage of the BIS text set is that this text set is uniform for all the Indian languages and again there is one uniformity in the Indian languages is that all are SOV structured language এটা কিবা এটা যদি পারফরমেন্স ইংলিশত ভাল হ'ব পাৰে, it may not be applicable to Indian languages to some extent because maybe of the structure. Okay, so here we have two texts, one from the CIIL Mysore. It is an institute in India where linguistics, they study about the structures of the languages, of different languages of India, which are, some languages are there which are not available in written script, but they take some other language script. So they study all these type of languages. So texts basically for SMS we have two. So not going in the depth. Okay, so CIIL, it is the Central Institute of Indian Languages, which is situated in Mysore, and they have for all the Indian languages. You can, by searching in the internet, you can see availability for other Indian languages also. So here I am giving a difference of the text set. Both are using different. Tumalke etia a technical kotha por iman buji nopara because you are new to this topic. But what I mean to say is that the way of tagging is different for both the text sets. So here, in case of BIS text set, they don't go in depth. They just specific pronoun, PRP. But in LDS, they had used it personal pronoun, ami. There are so many pronouns are there, but they had given it specific. Then for school, it's a noun, but they had given it in a way, here in different way. So there are some techniques how to identify it, but they have their own individuality, means tahator nijor kisuman importance ase. For that purpose, both the text sets are important. Okay, depending upon our use, ami kuntu weight use koribo bisaru, hetu upor etu text set important hoy. So same thing, I had given an example. So models which we used in POS tagging. So rule-based POS tagging. So this is which we do it manually. Earlier, when there was no deep learning or AI concept properly, this rule-based concept was used with the manual effort of the linguistic expertise. Then we have the stochastic models. Okay, it is pure technical. Just for the names, general information. So these are the models. Then machine learning based models, decision tree, SVM. Then deep learning, which is the recent trend, we can say, which most of our work is going on in the Indian languages. So these are the deep learning, LSTM, BiLSTM, CNN. This model is basically used for images, but nowadays it is also used for this POS text, for the text also. But in the last session, in a discussion, they were talking about this BERT model. So here I have specifically mentioned that BERT is still to be used, means it is, we are not, we are still in a very initial stage, we can say, and it is not yet trained properly. So no doubt we are using these translations and many digital way of communicating in SMS, but still for good accuracy, still it is need to be done. Okay, okay, so various hybrid models are also being used in this research work. So LSTM, BiLSTM, CRF, all these are being used. So this model itself is a specific area of research, which it is not possible for a short period of time. So now I am just showing you one graph. here these are the work done from 2020 to 2025 on BIS text set, specifically on BIS text set. You can see for Hindi, Bengali, Tamil, Assamese, Gujarati and Kannada. Means there are other work also, but with the use of BIS text set, these are the work done till date, and with the LDCIL text set. So these are the work done. So we can see that compared to the LDCIL, the work in BIS is still less, because the BIS text set is in general for SOV structured language, whereas LDCIL, no doubt it is SOV structured, but it is little bit language specific. Okay, so this is one of the results which I had done with my research scholars. So this is one of the paper which has been recently, just recently it came to the, just a few days back it came to the internet. So where all this work had been done. This is another work with the, this is done with the help of LDCL, but it is not yet in the web, means internet, yet to come. It is done with the help of LDCL text set. So future direction and conclusion. So resource development. Now one more thing is there. No doubt we are creating data set, but still that data set which are done in Indian languages, it is not the gold standard annotated data set. In English, the gold standard annotated data set is being already built, so we can compare the things, that whether it's a good, means accurate one or not. In the last session also they discussed about the fake. Suppose an image, suppose not only in this computational linguistics, anything for it, whether it's an original or fake, how you'll identify. No doubt work is going on, but in order to confirm that it is the original one or it's a fake one, you should have a gold standard annotated data set. If it is a not gold standard annotated data set, how much we say it is 90%, 99% accuracy? No, it is not correct. Okay, so in case of the Indian languages, no doubt we are getting good results, but still there is shortage of gold standard annotated data set. So these are some of the improvements we have to do in case of SMS. That is also one, to develop the gold standard data set, need to be recognized from an international body. Okay, interoperability and RedPub with the POS tagging as the backbone. Then only we, if the POS tagging is not correct, tagging means if the computer doesn't understand that word is correctly interpreted with the parts of speech, then it may interpret with a wrong output. Okay, so whatever we do, if the POS is not correct, just like আমি যিমানে পঢ়মু লাগিলে যিয়ে কৰো লাগিলে আমাৰ যদি গ্ৰামাৰটো আমি ভালকে নকওঁ, আমাৰ গ্ৰামাৰটো ভুল বুলি কয় নাই, ঠিক তেনেকা আমাৰ POS টেগিংটো যদি ঠিক নহয়, কম্পিউটাৰ ক্ষেত্ৰটো হে একে ধৰণৰ হয়. Just the difference is that the other one is with respect to human beings, class, English grammar and language, and here it is with respect to computer, or you can say the artificial world. Okay, so with this I come to an end to my talk. Thank you for the patience hearing. Thank you.
Thank you, ma'am, for your insightful words. Now that concludes this session. Thank you all for your participation and insights. We will now have a break for lunch. I hope you enjoy your meal and will soon reconvene at the next session. Thank you. Students are requested to move in a queue to avoid crowding, please. Sir, lunch to Vishwanta
বহুত টাইম লাগিব লাইভ হৈ গ'ল লাইভ আছে মিটিং জইন কৰিলে আহিছোঁ লিংকটো দি দিছোঁ ষ্টাৰ্ট হৈছে মিটিং ষ্টাৰ্ট দেখোন
A very warm good afternoon to our respected guests, scholars and students. I hope you all had a very refreshing lunch. As we resume our conference, I would like to take a moment to express our appreciation for the esteemed guest among us. To begin with, it is my privilege to felicitate Professor Nityanand Sarma sir from Tejpur University for his outstanding contribution to academia and research. His dedication and expertise have been instrumental in shaping the academic landscape, and we are truly honored by his presence today. So I ask Kankita to please felicitate sir. It is also my honor to invite Professor Nityananda Sarma sir to deliver his plenary talk with us. With his vast expertise and insights, we look forward to an engaging and enriching session.
PPT. You have that one? Slide center? Huh? I think it will be okay. Yeah. I hope I am audible. So, good afternoon to all of you. It's my privilege, okay, to give that keynote address in this conference, National Conference on Multidisciplinary Approaches in Networks and Computing 2025. So I have actually selected the topic, the collaborative spectrum sharing in cognitive radio network and issues and challenges. So in this talk, basically I shall talk about what are the challenges and how this can be tackled, and what are the possible uses of this technology, because in our group we have developed some techniques which are used for handling different issues. This is the just outline of my talk, and basically let me first introduce, I think some of you might have the idea that what is a spectrum. Actually, there is a spectrum scarcity problem, because day by day number of applications that we use in our the digital or connected world goes on increasing, and crisis of that spectrum is increasing day by day, because there is a limited license spectrum on which services can be run. And it is expected that as per the Cisco report, the global mobile traffic in 2027 will cross 288 exabyte per month. So we can imagine actually how much of traffic we are generating, and all of them are using the spectrum. Fine. So here, so on the other hand, there are some observations that it is found that most of the licensed users are not using the spectrum, and it remain unused, but it cannot be allocated to somebody because these are already allocated, and spectrum license user paid money and unlicensed user cannot use it. So these are the basic issues, and the cognitive radio will enable the spectrum sharing among this growing number of users, allowing the secondary user to opportunistically use the spectrum which are remaining vacant or you can say unutilized. So various spectrum sharing approaches now exist, and to maximize the efficiency while minimizing the interference to the licensed user, because unlicensed users should not cause harmful interference to the licensed user. This is an issue. And there are some examples, the two examples I listed here. One is called wireless rural area network. You might have heard about it. That is the latest IEEE standard called 802.22. That is called, that is to connect actually rural area to the cities with the help of some long distance wireless connection. How this can be possible? You know that most of the TV channel which were earlier running on analog signaling now remaining vacant. Therefore, this can be opportunistically used for providing long distance connection where there will be some base station. These are not actually cellular base station, because you need not have to pay money for that. It is an unlicensed, that means it will be free of cost. And government have the policy to use it, and most of the country actually this is done. In India also it is already implemented in some of the actually cities, rural areas where they can connect to that. So second one is called citizen broadband radio services. I think there is a very interesting service mostly now in US.
the spectrum which are remaining vacant are actually stored in a geo database, where from I can see, suppose today at this time, which are the channel which are free, or how long it will be free. This can be recorded in a database, and the applicant who may be service provider, they can apply for that to use those unused spectrum, and this will be actually provided to them in exchange of some kind of revenue, so that they can use it without disrupting now service. So these are the, I think in the diagram I am showing you, that this is the spectrum measurement or spectrum utilization scenario. You can see most of the cases these are remaining unused, and also we cannot allow somebody else to use it because licensed user have already paid money to use them. This is how spectrum remain actually free. You can see in the different time as well as different frequency level and the power level used by different frequencies or become spectrum. That means if these are called spectrum hole, if somehow we can detect these holes and use it in a very intelligent way, then we can now solve the spectrum scarcity problem. So this is the main aim of the cognitive radio concept. It was coined by Joseph Mitula in 1990s. It is for opportunistic exploitation of the unused spectrum. So CR or cognitive radio is a context-free, you can say context-aware intelligent radio, which have two capabilities. One is cognition, that means it can sense the media or environment and detect the presence of signal or some vacant, you can say, spectrum. And second one is adopt its transmission behavior called reconfigurability by according to the spectrum behavior of that particular area. So now in this, by using this kind of vacant spectrum, we can define a network. That means unlicensed user can now use this unused spectrum for communication. There are generally two types of user present in the cognitive radio network. Primary user, who are the licensed user, who have the exclusive right on the spectrum, they can use at any point of time. But secondary user, who are actually the temporary user, who can use them without disturbing now primary user, and they actually have to somehow detect which part of the spectrum is free and accordingly intelligently detect it and use it without causing any harmful interference to the primary user, because that is not acceptable. Now generally CR paradigm, we have actually three kind of uses for the secondary user. First one is called underlay. Here both primary user, that means licensed user, and the unlicensed user can communicate at the same time, provided the unlicensed user communication should not disturb the licensed user communication. That means if they maintain some power level that is below a threshold, it may be possible. But as a technology, underlay technology is very difficult to realize, because if somehow the power is leak out, then it can disturb now the primary signal, and it is not acceptable. Now second one is interwave, which is a very nice one, because here secondary user can use a spectrum if no primary user exists in that particular spectrum band. That means there is no possibility of causing any harmful interference to the other side. The only problem here is we have to correctly detect the presence or absence of secondary user. So third one is overlay. This is again a very interesting technique where primary and secondary user can collaborate. Here actually secondary user can help the primary user for relaying the data of the primary user, and that way the primary user can give the secondary user some amount of reward as a spectrum access right, and they can utilize it. So these three are very interesting paradigm, and I mentioned that first one, due to some problem, technological problem, is not popular, but the second one is very popular, and the third one is also getting popularity. Okay, so let me mention about the cognitive radio 4 functionalities. These are very important. First one is spectrum sensing. By cognitive radio, I mean the secondary user who want to use the unused spectrum. okay, in a very intelligent way without disturbing ongoing primary communication. So first one is sensing. Sensing must be very accurate. So there are a lot of actually, you can say conventional sensing, spectrum sensing we can use, like energy based, mix filter based, psychostationary based, like that. But these are actually having some problem. We'll discuss about it. Then spectrum decision, once spectrums are sensed, so we should be able to find out which of the spectrum is very good quality to use it. That is the decision. Then sharing, which I'll be talking about. So how to share down the free spectrum in a very judicious way so that we can improve now efficiency of the spectrum. That means we can actually allow more and more user, okay, in that particular unused spectrum. Then spectrum mobility, that is again a very important function because CR users are using licensed spectrum on a temporary basis. If somehow primary user comes back, it is the responsibility of the CR user to leave the spectrum, okay, so that primary user communication is not disturbed. So these four are very important functionality. Okay, let me talk about now spectrum sharing. So spectrum sharing, here I talk about now collaborative approaches to spectrum sharing. By collaboration, actually we talk about two kind of collaboration. The one collaboration where primary user and secondary user will collaborate. You see, primary user, the licensed user, and why they will collaborate with the secondary user who are unlicensed user. There is no record of secondary user. So in that case, we can have a very good, actually, the framework. One of them is auction. What we can do, primary user, whenever they are not using the spectrum, okay, they can auction it to the secondary user and earn revenue. This is by way we can improve the performance. The second one is, what can be done? Sometimes primary user cannot cover some area. As for example, there may be some gray area which primary user cannot cover. As for example, inside the room, there may be a case that some signal cannot reach the room. If we can put some interfacing, you can say, device which can receive the signal and relay to this room, you can see now people will be benefited by that. So secondary user provide this kind of relay service, but in return, they will be allowed to use the spectrum for some amount of time. So this is another very interesting, okay, technique. But the first one that I will be talking about is called, there are two types of collaboration. I mentioned that primary and secondary. The second one is secondary collaboration. Okay, here are the first one, sensing-based collaborative model. Here, the primary user will not be involved. It will be the responsibility of the secondary user to detect presence or absence of channel, or you can say signal in the channel, so that they can utilize it if it is free. But one important thing is that the detection must be very, very accurate. We cannot compromise the quality of signal of the primary user. Therefore, it is actually found that if I suppose claim that my device can clearly detect, okay, 100% it can accurately detect presence or absence of signal, but no one will trust on that, because if somehow I make the mistake, then primary signal will be corrupt. So how to do it? For that purpose, one very good technique that is popularized is called geographical database-based sensing. What is that? Actually, we know that most of the channel, licensed channel, in some area may not be used for some period of time. Okay, we are sure, suppose some TV station will not broadcast program within this time. We are sure. What can be done? This can be stored in a database. So anybody who wants to use that channel, it can check the database, get the data, and use it. You see, in that way, we can make it sure that there will not be any disturbance to the primary user. And this becomes so popular, that's why the CBRS, Citizen Broadband Radio Service, become very popular. In India, due to some regulation problem, this cannot be done. In US, it is so popular. Suppose I am a service provider, and I want licensed spectrum. I think you understand, if we talk about 1G, 2G, 3G, 4G, 5G, and the TV broadcasting, radio broadcasting, everything, most of the radio channels are already occupied. And government earn money from that. But we don't have free spectrum to be allocated to a new service. So how to get it? But we know that there are some actually users who are not using it. Okay, can we use it? So that is the technique we can use. Okay, that's why database can be maintained. And we know that gradually all analog television programs are withdrawn. Therefore, that part of the spectrum become free. Okay, one example is Durasan. Okay, who government allotted lot of spectrum to them, that become free. Actually, we can use it. And this is already used for implementation of WRAN, wireless rural area network. I already mentioned. Okay, like that, there may be some spectrum that can be utilized. And in US, what happened? In the actually daytime, the spectrum allocated to radar service, okay, are not used. They are only for night radar. What happened? This particular spectrum, okay, they allow now private parties to use it and to run their service. That way, you see, government earn money from that. Otherwise, the radar spectrum was allocated to government authority who will be using it. So that way, we can accommodate, and this is how, by using the database, we can avoid the problem of spectrum sensing. Okay, here I am actually showing you the example of WRN. Here, this is the base station, and these are the customer premises equipment, and they can communicate. And remember, this is a long distance. This is not simple Wi-Fi. It may be of the order of 10 kilometer, 15 kilometer. Okay, this is like a cellular network, but without paying money. It's a free of cost. Okay. Now next comes the relay-based collaboration. I already mentioned what happened here. Secondary user will provide service to PU, the primary user or license user, the relay service, and the primary user will allow now secondary user to use their license spectrum for some period of time. It's a win-win situation for both of them if they collaborate. So here, in this example, I am showing you these two primary users. They want to communicate, but due to some problem, they cannot directly communicate. Maybe signal attenuation or some other problem, fading problem, but they can take help of the secondary user to relay the signal so that they can effectively communicate. The next one is called auction base. Here again, it's a inter-user, that means primary user and secondary user. Here, primary user can now auction their spectrum, and secondary user who want to get it have to bid for that, and the winner can use the spectrum by following the rule and regulation set by the auctioneer. Auctioneer will set the rule and regulation how long this can be used, like that. And we know that spectrum, in India, in all over the world, we know that spectrum auction is a big business by the government. Government earn actually majority of the revenue from that. Okay, but here we talk about temporary spectrum auction. Okay, and this should be very, very dynamic. Okay, it's a market-driven approach where secondary user bid for the spectrum resources, and auction can be centralized. Generally, we know that there has been an auction house or called auctioneer, where what happened? The first of them, primary user will now give their ask or the money or the price. Then the bidder have to bid for that. The highest bidder will be the winner. And we have different auction theory, and we know that we may go for the second price auction, we may go for the English auction, we may go for the Dutch auction, like that. There are so many things. So that can be applied here. Then there are two kind of things. Actually, it ensures the fair pricing and efficient spectrum allocation, because here everybody will be eligible to apply for that particular auction. They can go for the bidding. Therefore, it's a fair allocation. Whoever will be bidding highest will be the winner. Then there are two ways how this can be handled. By using now Bayesian game, actually, we can make it distributed. If we assume that auction house is not there, there must be somebody actually who will do that. So in general, we have a central body who will regulate the thing. But if we have no central body, then this should be done by the node themselves. Then it becomes a game theory, and we know that Bayesian game can be used for the modeling of the auction. Okay, so this is how this can happen. I have shown here centralized approach where we have an auctioneer, and we have the PU who will now give their ask or the bid, the price, or with the reserve price sometime. Then the SU will bid for the the particular auction channel or spectrum. So if we see now history, the sensing-based collaborative approach, then initially the CR actually research started with sensing. How to accurately sense the spectrum. This is the main focus. But what happened, there are some problem in the independent sensing. Independent user cannot accurately sense the spectrum. If we have spatial diversity, because signal present here may be some amount, maybe in other place some big amount, we should not actually misinterpret that. Actually signal present. So how to do it? You can do it with the help of collaborative approach. One of them is called collaborative spectrum sensing, and this can be done by using cooperative game theory, where multiple users having some objective will now cooperate to detect the presence or absence of spectrum. And here actually we have something. The first requirement is that I already mentioned, the detection accuracy should be very, very high. It should be almost 100%, because if detection accuracy is less, we misdetect something and we may disrupt primary user communication. That is never acceptable. The second one is false alarm. What is a false alarm? We know that we will falsely detect that spectrum, the signal exists. This may lead to inefficiency. Actually, there is no signal, but you say that signal exists. Okay, that is not so dangerous, but from efficiency point of view, it's not good. Therefore, instead of doing by single one, what we can do, the multiple user can sense it, okay, and we can collaborate it and to come up with a maybe common decision whether spectrum exists or not. But here there is again problem. The problem is it will improve detection accuracy, yes, but false alarm will also increase. Okay, that is a problem. Therefore, it's an optimization problem. If we try to reduce one, okay, the other will shoot up. Therefore, there must be something we have to devise so that we can control. Okay, maybe the false alarm acceptable level will fix it. Then we try to improve now detection accuracy. So that may be the way to handle it. And there are a lot of cooperative spectrum sensing where multiple secondary users will share or collaborate their sensing result to come up with a common, which is a more accurate one. And these are the different ways how this can be done. You can see the different users collaborate. There may be a fusion center where we are fusing the result, or maybe with the help of some kind of relay we can do it, or with the help of relay we can do it, or we can do it in a distributed way. Suppose this is a distributed way, user exchange with the peers, then they come up with a decision. Here they relay, because these cannot directly communicate with that. With the help of relay also they can do it. These are a different paradigm in which based on the requirement you can use it. Okay. Now I will talk about here on sensing based collaborative approaches that our group we work on that. The first one is called multi-objective collaborative spectrum sensing. This is for single channel CRM. We have a single channel, okay, what can be done. So this, for that I already mentioned, if we try to now increase now throughput, okay, that is our main objective by minimizing the false alarm. That means signal does not exist, but we say that exists, okay, that probability we have to reduce. So there are, that will also, the penalty due to misdetection may get increased. You see, if we try to reduce false alarm, misdetection rate also increases. That is a severe problem. Then trying to now improve sensing accuracy by engaging more number of SUs in the cooperation increases the energy significantly, because you know that most of the cases wireless devices are running on battery power. We should be very, very careful, because whenever they are involved in radio communication, a huge amount of battery power will be consumed. Therefore, we should try to avoid unnecessarily doing now sensing. Okay, so that is a very good problem. That means how many of them should sense so that we get some acceptable level of, I think, result. If we engage all of them, that this is not acceptable, because huge amount of energy will be consumed. So that is again a good thing that we have to address. Relative impact of the throughput gain, penalty due to interference, I already mentioned this is due to actually misdetection, and energy overhead, that is due to unnecessary sensing by some SUs. These are addressed by multi-objective optimization problem. Using now weighted, because we develop actually 3 criteria for optimization, and this is a multi-objective, therefore we convert it to single objective, okay, by weighted global criteria method. I don't know, some of you may be aware of that. This how to handle now multi-objective problem. Now throughput gain, penalty, and the energy overhead. I think I will not go to detail, maybe you may be somehow confused. Here what we are doing, we try to now optimize multiple objective, and it's a very challenging problem. Okay, it's a NP hard problem. Therefore, we do it by some heuristic method, okay, and getting something suboptimal solution. Okay, that is our aim. Actually, these are the formulation. I just show you how we did it. Okay, then we have finally actually for a group of actually secondary user, we define now utility function like that, because there is a penalty due to misdetection, there is a penalty due to energy expense, and this is the throughput. That is the positive thing. That is called gain, collaborative or cooperative gain, and cooperative loss. So we have to balance that. And these are the work we have done it, and I think it's a very good thing. Then next, coming to utility aware, again collaborative sensing, scheduling scheme for multi-channel CRM. Here the problem I will tell you. Actually, you see, if we do the sensing on only one channel, this is not advantageous, because you have to find out which are the channel which are free. But suppose there are 10 number of channel, at that moment any one of them can be free. Then in a sequence actually we go on sensing. Please remember, the channel become free, again busy, free, like that. It's a time varying nature. Okay, what is the probability that if we sense a channel, you get it free? Then it will be advantageous for you, fine? But here deciding the order is a major problem. If we go in a wrong way, because you have already consumed time, and there will be only little time left out for actual communication. Therefore, scheduling is a major problem. Okay, that should be handled by something. Okay, so that is done by, we do it with the help of some kind of, actually, I will tell you something. We assume that, suppose probability of idealness of channel, these are given to you. Okay, then in that case, the order in which you have to sense the multiple channel will be the one with the highest probability of to be ideal. You sense it first. But if we go in the reverse direction, you will lose lot of time actually in doing unnecessary sensing. Okay, so this is how we did it. Okay, and we try to maintain now the balance so that more and more actually free channel can be exploited within a given period of time. That was the aim. Again, we developed now heuristic thing and the optimization problem, and we solve it. Okay, and I just quickly go through it because it won't be possible to cover everything. Then cooperative spectrum prediction driven sensing. This is again very, very interesting. Previous one, I talk about that prior probability is given to you. Okay, but what we can do, we can use the machine learning, maybe time series analysis we can do. So what we have done here, we have done now with the help of LSTM, long short term, okay, the memory based learning, fine. So for each and every channel, we now record now history of its busyness and freeness. Okay, that means we get the history, then we train it up, then we see in the given time slot, on the next time slot, which channel will be free or which will be busy. Okay, because we are doing it in a collaborative way. So we are putting now this actually learning model in each and every individual, okay, sensors, individual secondary user, and finally we collaborate it. As for example, suppose someone is saying 1, ones means busy, 0 means free. Okay, but we have a 10 user who will be giving us. So it's a mixture of zeros and ones. Suppose 5 of them is saying 0, 5 of them is saying 1. So it will be 5, am I right? It will be 0.5. Okay, so what we have done here, if it is a 0.5, so it's a really challenging. We don't know actually, it is an indecisive one. fine. But if it is suppose 7 or 8 or 9, it's a decisive one. So for the case of indecisive one, we do a real sensing. Yes, we verify by physical sensing. But for the decisive one, which is the good value, we simply skip it. Suppose we want to, we get it 0, that means we are freely use the channel. So this is how we optimize the thing. Okay, it's a very simple, okay, the idea, but it gives us a very good impact on the result. Okay, so what I am showing you here, okay, that is how it is done. Okay. So now coming to another issue that we want to address, that is now we in the case of collaborative approach, there are 3 phases generally we follow. The independent who are part of the collaboration, they will be sensing the spectrum, and their report will be submitted to a fusion center or maybe collaborative head, who will be finally deciding on the basis of the thing, and it will be again the decision will be sent back to all the members. Okay, so one major part is the reporting, because all members will be reporting their individual decision, and this should be fused. Now what we have used here, it is found that sometime we may stop reporting because reporting is consuming energy. As for example, instead of reporting in each and every, okay, SU, fine, this is the normal one. Suppose the sequence in which we find now the spectrum busy, free, like that. Suppose we find that for 5 slot, spectrum is busy. That means 0, 0, 0, 0. Now it is observed that what we do now, in the first one we send 0, but because there is no changes in the next 4, we don't send. Okay, we use a milli-machine based approach. Again, you may be knowing that finite state automata we can use. We model that, okay, and we found that the huge amount of energy can be saved by that. This is due to the actually nature of the primary spectrum. You know that each and every spectrum, there is a on-off pattern. On means signal is coming on the spectrum, off means no signal. Fine? In some cases, there will be major portion will be on. It's a continuously busy, then free. Again busy and free. As for example, for web browsing, the moment we actually download the page, you see quickly it is coming, it's a on. Then user will be looking at it, then again click. You see user looking at it without initiating any communication, that means off. Channel is not used. Okay, that way for different communication there will be a, you can say, uses pattern. That pattern can be learned, and therefore it will be very much helpful in doing that. Okay, and we found that it's a very, very effective in reducing now amount of this thing. I already mentioned we use a milli-basin based approach to model it. And finally, that cooperative prediction driven channel switching scheduling scheme. Actually what we do here, generally what happen, if we suppose we have now multiple channel, fine, then what happens, suppose there are some channel which is at that moment this is free, no doubt. But if we start using it, it's possible that immediately primary user may come back. Then we have to vacate it and we have to search for another channel. Okay, why not at the beginning you be careful, you predict it in future, is it possible that primary will come immediately? If not, better select that channel. Okay, what we do based on the user requirement, we sort the channel, okay, by applying the prediction, and we pick up those channel which will be highly probable that, okay, it will be free in the future. Accordingly we assign it so that channel switching delay can be reduced and real-time application can run on the secondary user without any effect. It's a very good example where we can do it, because generally what happened, it is understood that most of the cases, you know that emergency network, suppose do you have a network for emergency service? Suppose we don't have. What we can do now, because we have so many services running in our system, some of the channel will be free at a particular point of time. You can run your emergency service there. Am I right or not? Okay, but emergency service, there is no guarantee that you will be continuously using it. You will pass on only some messages, small messages maybe. But if we run, suppose, real-time service, like video, something, you cannot. In that case, you need a very good quality, okay, channel which will be free. Okay, so these are how we have done it. I have already mentioned that we did it actually multi-level again, prediction and collaborated, and finally doing that. Okay. Now, these are some of the applications I want to mention. That smart city and intelligent transportation system. This is a very good, okay, application on that, because in that case, what can happen? The traffic signal roadside unit can work as a collaborative secondary unit. They can sense, they can send it, and they can find out which channel is free, and they can establish the network dynamically. This is a very good application. And 5G and 6G network for ultra dense deployment, because you see this cell become denser, and once it become denser, then we need more and more channel. Fine. So in that case, we can use this approach, sensing based approach, to apply it, so that we can make the capacity of this network higher. Then industrial IoT and smart factory. This is heavily where we use machine to machine communication. Disaster recovery and emergency network, rural broadband and community network, I already mentioned about it. TV white space, that is actually TV channel which are using analog signaling, are free, okay, that where we can run actually wireless rural area network. And this is the frequency band that is generally used for that purpose. 54 megahertz to 862 megahertz. Okay, and smart grid communication for energy network, and this is again we can allow now collaborative sensing, and which allow now smart meter and power grid to access the ideal spectrum and communicate, so that we can monitor now power uses, or we can distribute the power very effectively. And these are the challenges: high risk of interference. The second one is false detection error. This may be another case. Inefficiency in spectrum utilization, because SU may vacate channel unnecessarily due to inaccurate sensing. That is one problem. And finally, the security concern. You see, we generally assume that in collaborative approaches, all users are genuine user. There is no malicious user. But it may so happen that some of the malicious users detect now the spectrum as free, but they report it as available or report it as busy, because by doing that, they can use the spectrum for their own purpose. Okay, they can malfunction, okay, and they can do something in a malicious way, and this is one of the challenge. And now next, coming to the work on the relay-based approaches, I will quickly proceed, I think. In that case, basically what we did in a relay-based approach, we divide now whole time span into two actually half. In the first half, relay-based operation is taking place. That means secondary user now take primary user signal, and it will relay it to the primary receiver. Then due to that, actually some extra time will be given to the secondary user where it can transmit its own signal. This is how we can divide the spectrum on the basis of time, but we can also do it on the basis of bandwidth. That means the bigger bandwidth we can have into two halves. The first half for only primary communication, whereas second half for secondary user. That means in the first half, secondary user will work as a relay to support primary user communication. Therefore, as a reward, it will be getting now second half. Therefore, we model it actually these two optimization problem, how to fix it. Because until unless secondary user get the proper reward, it won't be able to provide the service. Similarly, primary user also want some quality service from the secondary user, because this should be win-win situation for both of them. It's an optimization problem from both perspectives. Therefore, it can be very nicely modeled with the help of matching theory. Okay, we have two actual group of users with different preferences, and we can apply now matching theory, and we use the matching theory happily here, okay, to solve the problem. Okay, I think Then the last one we talk about is energy harvesting. I think we know that nowadays there is a crisis of energy, how to conserve energy. So what can be done in the case of wireless device? As a relay, whenever it is receiving now primary signal, at the same time some portion of the power of the primary signal can be used in as a harvest power. That means it can be used for actually recharging some battery of the secondary user, and that power can be used for again its own transmission as well as for relay purpose. Again, it can be now modeled in two perspectives. One is called power splitting. The given power is split into, because received signal is split into two parts. One part used for decoding of the signal. Second part is used for harvesting. Fine. This is one. The second one is we can split it into two parts according to time. Actually, first very beginning, one portion is used only for harvesting. Rest of the part is used for information decoding. Okay. So what we did in our scheme, generally in the literature it is found that either they are doing power splitting or time splitting. We hybridize it and we try to balance it, okay, and design again a multi-objective optimization problem and frame it again finally with the help of matching tool. Okay. For matching again, for finally actually making the cooperative group, we have used hedonic game theory. Okay, that is one of the very good application here. Okay. And in fact, what I want to mention here, that is the basic thing. So primary user cannot reach actually secondary user directly. This is the primary user. It cannot reach the secondary user directly. Therefore, it takes help of the relay. So relay will help it in doing that. Okay. But relay needs some reward. It cannot do it without reward or without or free of cost. So this is how I mentioned that we have actually splitting of the whole bandwidth into two parts, splitting of the time into two parts. This is bandwidth, two part, and this is time. Okay, so this splitting can be done and this splitting can be done. Again, this is an optimization problem. What fraction used for relay, what fraction used for your communication? That is a parameter that should be properly adjusted. Okay, that is a decision variable that should be determined. Okay, so we model it like that, and we solve it because it's a again multi-objective problem, and we did it with the help of a heuristic method. And there is a we have a problem solver again. Okay, and we also use the problem solver to get the solution. Okay, but it is a very slow, and we compare our result with that. Okay, this is how it happens. Okay, I just skip this part maybe. These are the different thing, and finally I want to show you how, you see, we are using the many-to-one game, one-to-one game for matching actually primary user to relay, because we have lot of option for relay. Which relay is the best relay, which can provide service to primary user, whereas the relay should also be benefited from that. Okay, so it should be a win-win situation for both of them. In the matching theory, generally we know that in the deferred acceptance, okay, what happened? Primary user will first declare their offers. These are the offers. Okay, the secondary user, what they will do, they will run the optimization problem and they will determine the factor. Okay, then they supply this factor back to the primary user. Now primary user, by looking at the factor, it will find out which one will be the most preferred one. Accordingly, it will now make the final preference list, and game theory started from there. Okay, and you see that secondary user, the proposer. Okay, then the primary user will be now primary user will be the proposer, and secondary user will go on checking. Okay, and it will be rejecting some of them. It is found that in this actually matching, primary user will be always optimized, whereas this matching is stabilized. It's a stable matching. We proved that, but it may not be optimum. It's optimum from primary user perspective because it's a primary user is the proposer, because we play one round for extra round for that. Okay, and this is very interesting, and it is found that secondary users are somehow victimized. Yeah? Yeah, supplicant. Deferred acceptance, because in that supplicant, one of them will be proposal. This cannot be optimal, okay, in both sides. One side will be just stable, other side will be, yeah. Proposer will be always optimal. Yeah. Supplicant, yeah, supplicant. So these are the example I want to mention again. The coverage area extension is a very good example of relay-based, okay, that cooperative communication. Then the unmanned aerial vehicle assisted spectrum relaying for disaster recovery. Suppose we have now unmanned UAV flying here, and there is no communication mechanism available, okay, because they can sense and find out and provide now the last mile communication facility to the area so that they can access it. That is a very good thing about, okay, application of the relay base. Then the vehicle to everything is a very good thing, because there is no predefined, you can say, channel, okay, and some of the thing will be not reachable, okay. So in that case, relay will help it to do the communication. Then Internet of Things in agriculture and rural areas. Underground and tunnel communication, it's a very good one, because we know that inside the tunnel, no communication link is available. So we can put in the end of the tunnel some relays, so which can provide the service. That these are also a good thing. Edge computing and fog networking, there also we can use it. The challenges are actually here incentive alignment. I already mentioned, why would secondary user relay without proper incentive? That may be a conflict area. Extension to multi-hub collaborative, okay, communication in relay-based cooperative model. Then increased latency in relaying. Actually, what happened? If primary user could have directly reached the other user, communication could have been instantaneous. But with the relay, actually, it introduced some delay. But the good thing is that signal quality will be boosted. Okay, that's why in some application, maybe real-time application where delay sensitivity is important, we may not be able to use relay. Okay. Then security concern again, relay could be also malicious. Okay, they declare that, okay, after the agreement, okay, after matching we found that, okay, this is the base relay, but what happened intentionally, okay, to actually attract now primary user, it okay, it gives the service with low cost, then finally capturing the whole communication. Okay, that is a big issue. Okay, in our work actually we assume that none of them is malicious, otherwise the whole thing will change. Okay, it's a really challenge. Now coming to the last part of my talk, that is the auction base. Interestingly, what happened actually here, it provides every bidder equal opportunity, okay, to win, and reduces the communication overhead with seal bid, because here we use actually seal bid, that is also called single-sided bid. Okay, only bidder will bid. Then you see that in that case seller, they have already fixed the price. They will not again do the sending now new price. Okay, that is to make the system efficient, also to make the thing communicationally, okay, from communication perspective very efficient. There are CR constant, dynamic impact spectrum opportunities, and difference in channel availability time. Actually, these are the two dynamics that are very important. You see that from all secondary users' perspective, all spectrum may not be free. That means they have different kind of dynamics, as well as availability time of each and every user will be different. Okay, so majority of the auction model deploy now double-sided auction, which aims at good revenue, but fewer channels remain unused. But here we use single-sided because our aim is to use the unused channel as much as possible, not to generate revenue. Here, what we did actually, we asked the user, secondary user, to bid for the channel, but that bid will be in terms of data rate. Okay? Once a secondary user bid for a higher data rate, that means spectrum is used now efficiently. That is our aim. So once bidder lose actually one round, in the next round, it will now increase now, okay, that bid value, and it will again go for auction. So that way, what we are doing as a revenue, we are actually getting more and more data rate, and we assume that data rate is the revenue. Okay? Okay, there is no actually, you can say somebody will be making profit out of that. Okay. There is an equivalence between data rate and revenue. Okay. And these are the actually 5 thing contribution we have. First one is in fact single channel, single winner allocation for homogeneous channel. We have actually each and every actually secondary user will be assigned at most one channel, and a particular channel can be allocated to only one user at a time. That is our first restricted, you can say. Homogeneous channel means all of them are equivalent. The second part, we talk about heterogeneous. Here, channel quality will be different. Some of them may be high data rate, some of them will be low, higher bandwidth, okay? Error may be more, error may be less, like that. And here, what we talk about, again, single winner, single channel, single winner. That next comes single channel multi-winner. What is that? Because generally what happens, due to spatial diversity, some signal, okay, if communication is happening in a particular spectrum, it may not affect some other area. We talk about actually non-interfering devices. Suppose these devices are communicating here, but their communication will never interfere with this communication. Therefore, same channel can be reused. What we apply here, multi-winner. What we do now here, the non-interfering user, okay, at the time of bidding, we group them, okay, as a group. And they group-wise, they will be bidding for the channel. In the group, there will be multiple bidder again. There will be somebody who may be bidding for higher value. Now, winning bid value will be that higher value of the group. Again, what will be the actually price these have to pay? Again, we have done it because this is a group one. We want to maintain truthfulness of that. Okay, for that purpose, we did that one, the pricing, the payment mode, though it is a second, okay, in a different way, so that we maintain the truthfulness of the auction. Otherwise, auction theory requires that it should be truthful, so that no one can falsely put some value and get earn of that. Okay, this is important. And for your information, here bid value is nothing but valuation. In auction theory, I think you people know that whenever we want to get an item, I first do the assessment of how valuable it is for me. I put an internal value to that actually. This is called valuation. Then at the time of bidding, I will never cross that, because if we cross that, it will not be of any use to me. To have an utility or payoff, my bidding value must be less than equal to my valuation. Okay. Here what we do, but it is proved, it is proved already in the auction. If bidder bid the true valuation, it is always truthful. Okay. So that one we did it, and it is also individually rational. So these two property we prove for all cases. Yeah, actually, if bidding, because it will be victimizing. Am I right? If bidding is not truthful, actually it's not fair. It's not a fair action. Therefore, your mechanism should not allow it. Okay, your mechanism, because the pricing rule, the winner determination should be fixed in such a way that, okay, that kind of thing will not happen. But you see, in a centralized way, we can do it, yes? But once you go to the Bayesian game, yes, in the game payoff, you have to do it. Yes. Yeah, strategy. So, because we have not done that, but in our centralized approach, we have done it. So, accordingly, actually, what we did, truthfulness and IR to prove that, okay, we maintain our pricing and winner determination. We do the actually reverse calculation from that, because to make our method, okay, really truthful. Yeah, yeah. So these are the different things. In fact, we compare with all the most of the existing thing. Okay. So these are again interesting application. 5G, 4G network spectrum trading is one of them. I think you know that 6G government is yet to allocate spectrum. 5G also, you know that the latest in India, that spectrum allocation is decided by a document called, do you know the document of that? Frequency allocation, National Frequency Allocation Plan. Okay, NFPA. Okay, AP. NFAP is actually prepared by WTC, Wireless, okay, that one, Telecommunication Committee. That is one of the unit of the Department of Telecommunication. And that abide by rule of the ITU, International Telecommunication Union. And that is very, very interesting that we have only limited spectrum for 5G. Right? Suppose I want to establish a 5G network in a rural area where no network is there. What can I do? Maybe what I can do, there is an operator, okay, who have already got one license spectrum, maybe for 3G or 4G service, but not using anything. I can get it on lease and I can operate on that. So that will provide that facility. Okay. But this can be up to any scale. It can be inside the room also. You see, I'm talking about covering an area. You may cover up to any level. Scale can be anything, because it can be optimized. The only problem there is who will be actually controlling now auction. Okay, there must be some regulatory authority. Okay, you know that generally it is controlled by government agency, so that there is no fraud, nothing will happen. Okay, so spectrum sharing for private 5G, then IoT and smart city. Okay, then all these things, drone communication network, public safety, then blockchain-enabled spectrum market. This is a very good area. In fact, the security concern, okay, that can be handled by that, by putting a smart contract, okay, and all auction, the bid value that we have, that can be evaluated with the help of that. There will not be any fraud cases to make it fulfill. Because otherwise, how do you make it sure that auctioneer is not doing something wrong thing for it? Am I right? Because nobody who is trustworthy in a centralized system. Because if something is broken, then everything will be broken. Okay, so that is an interesting thing, and these are the challenges I already mentioned. It's a computationally very complex, because we did it in multiple round for each and every channel. Okay, we first in multiple round for each and every channel we actually do the bidding. If leftover time available, next level, like that, so that most of the channel can be occupied or can be now assigned. So it makes the thing very complicated, because computationally very complex. Okay, then collusion and fraud. It may happen that 2-3 bidder will be now coming together, okay, and they can do something. So that is again very dangerous. Trade-off between revenue maximization and spectrum utilization, that is an issue. If we try to improve revenue, some of the resource will remain unassigned. Okay, these are very conflicting things. Therefore, in our auction, what we did, revenue we make actually data rate, so that we encourage the bidder to go on increasing, so that spectrum utilization can be increased. Okay. Handling spectrum handoff and interference management, that is again, because these are the externalities. Okay, suppose you actually auction one spectrum, then after some time the spectrum vanishes, some other spectrum comes. But how do we handle that? Okay, these are not here. We assume that for the whole duration it will be available. To make it very dynamic is a difficult problem. And malicious auctioneer, I already mentioned. And fairness concern, welfare issues may always win. Okay, someone can falsely, because I want to be loser. Okay, beyond my valuation also I can beat. okay, to harm somebody, or maybe ego, to earn it. Okay, these are the things that might happen. So with that, I conclude. Yes, I'll tell you. Actually, there are some spectrum band. There is a concept called liberalized, okay, unliberalized. Okay, liberalized means in the spectrum band you can run any service. Suppose I am one of the spectrum owner. I get suppose 1 gigahertz to 2 gigahertz, right? I can run any service because this is a liberalized one. I have the liberty to run 2G, 3G, 4G, 5G. Okay. Generally, what happened nowadays? Government made most of the spectrum band liberalized because same operator, suppose 4G operator will be switching over to 5G. They found that the 4G users are reducing. Am I right? Spectrum is there, but no user. So they, in the same spectrum, they will be running now 5G. Okay, these are happening, and there are 3 ranges generally called high range, mid range, and low range. Okay, in the low range we have less than 1 gigahertz is called low range. All cellular thing up to 2G we run in low range, and also the TV program, most of them, you know, that 700 some megahertz, okay, all of them are below that. Then going from 1 gigahertz to 6 gigahertz, majority of the generation, cellular phone, they are running there. And 5G also, one person assigned to them. 5G assigned in this one of them. And also in the high range, that is 24 gigahertz to 60 gigahertz. The signal in that range become almost light. And most of the particle will now absorb the signal. It cannot traverse too much distance. Maybe hardly it will go to 100 meters. Okay? But if we go to the lower frequency, it can traverse long distance. Okay? That is important. Therefore, mid-range for the 5G is more desirable. People are talking about 3.32 something. In India also, 2.3 gigahertz given to 5G. Okay? It's a very good thing. Mid-range is very good. Signal quality, that one, propagation characteristics is very good. Yeah. Okay. You see, the thing is, one of the good thing about PDMA is that, okay, PDMA and CDMA, these are the 2 ways how you can use the spectrum, right? And both of them have advantages and disadvantages, okay? But as a whole, I think it will try to use the spectrum as much as possible to pack it, because it's a licensed one. You don't want to waste, okay, spectrum. But whenever we go for Wi-Fi technology, what happens? It's a random access, because free of cost, you are not paying money for the license. Therefore, you are free to use the spectrum, and you can maybe colliding with somebody like that. Okay. So here, yes, generally what happens? Wi-Fi technology-wise, Wi-Fi is very simple. You talk about your mobile. Actually, the technology is very complicated, because so much of synchronization, so much of rules must be followed. But moment you go to Wi-Fi, it's a very simple. You sense the area, nobody is doing it. But here you see, you wait for your ground signal coming from that. Okay, switch over to that channel, switch over to that time slot. Oh, you must perfectly synchronize. And also, you have to adjust your time. Okay, these are happening in this mobile. It's not so simple technology. CDMA, same thing. If the code word you use, am I right? It is something, because it should be orthogonal to other. If number of user increases, there may be overlapping, because it's a random number. 2 random numbers same in one sequence. Then that person will be corrupt. Right? Yeah. CDMA, good. Yes, CDMA, if we do centralized CDMA, good. But do not waste that, because we want to get the channel utilized by rural area, and this is broadband basically, broadband rural area, so that they can connect the internet thing to them. This is not for you can say voice service only. WRAN is broadband rural, right? And I mentioned that the TV spectrum is very good in propagation characteristics. Okay, that's why it can go to long distance without any problem. And the devices are very simple, low cost. These are the actually viable things. And it was, I think, the first project was run in India, in Tamil Nadu. Okay, one of the village area was actually covered by them as a prototype, then extended. It's a very nice one. It was run by a joint project by IIT Madras and Delhi. A group of people doing it. Now it is a standard IEEE 802.22. Yes. Yeah, what happened, you see, whenever we talk about this kind of optimization problem, no? In the quantum computing, this become very easy. Because you see, we have exponential amount of computation required, right? The moment you do quantum computing, your computation will be requiring polynomial time. That's all. Yes, we will be benefited by that. We need not have to struggle hard with the heuristic. Better go for direct solution. The benchmark. Okay. Fine. I think with that I conclude. Again, thanks for your time. And again, yeah. I thank now organizer for inviting me and giving me a chance. Hope this will give some idea what you can think and what you can carry forward, because this is always a beginning. You have to see the small problem can give rise to a lot of research direction. Okay, and it is better if we can also nowadays think about some prototype kind of thing. Okay, some idea might come out. Yeah. So it will be my the privilege to introduce. These are my collaborators, all of them my PhD student. Okay, they collaborated in the PhD research, and they did a lot of work on that. Good thing. Yeah.
Thank you, sir, for such an insightful discussion and session. Following this, we have an insightful plenary talk lined up. It is our honor to invite Professor Shikhar Kumar Sharma, sir.
Due to some other assignments, Shikhar sir could not join actually due to his schedule with convocation. So we will continue in the next session after a small break. Please arrange the tea till then. I need a favor from you all. If anybody has got good clicks, please share with me group photo. কাৰোবাৰ লগত ষ্টুডেণ্টৰ লগত ভাল ফটো আছে যদি
Everybody is requested to join us for a tea break. Respected esteemed guests, scholars, and students, I hope you all had a refreshing tea break and are ready to continue with the next session of our conference. We have an engaging lineup ahead, and I am honored to begin this session with a moment of recognition. First of all, it is an absolute honor to felicitate Professor Diganta Mukherjee sir from ISI Kolkata. Sir, we sincerely appreciate your presence today and contribution, and it is a privilege to have you here with us. As a token of our gratitude and respect, please accept this felicitation, sir. We also extend our heartfelt appreciation to Professor K.S. Malika Arjuna Rao, sir, from IIT Bombay. Sir, your presence adds immense value to this gathering, and we are truly grateful to have you here. Please accept this felicitation as a symbol of our gratitude. With this, we shall now proceed to the next segment of our conference, that is the paper presentation.
Please invite them. I will see. What size? By the way, NC19 বাইদেউ আহক ইয়াৰ পৰা দিব ইয়াৰ পৰা প্ৰেজেণ্ট কৰিব আপোনাৰ পিপিটিটো আছে মেডাম কৰি দিবা তাই কৰি দিবা সেইবিলাক হাত লগাবা কৰ্ডলেছ মাইকটো ক'ত গ'ল বেটা
How much time do you need?
Human time maybe 12 minutes you take
12 minutes? Good afternoon. So we'll start the session. What is this? Track 1 of R3, R4. What is the session called? Alright, anyway, so whatever the name, track 2. Yes. Track 2. And our first speaker is Dr. Ranumani Borua. Not Dr. yet? Okay, soon to be? Yeah. Okay. And the title of the talk is Optimal Pursuit Evasion Strategies in the Lion and Man Game Induced by Penalty Functions and Strict Betweenness Relations. So you have 12 minutes? 12 minutes? 12 minutes? Okay.
Good evening, everyone. Myself, Ranumani Borua, is going to present before you the paper on optimal pursuit evasion strategies in the lion and man game induced by penalty functions and stick-betweenness relations. So that's correct. This paper extends the classical lion and man pursuit evasion problem by incorporating penalty functions and stick-betweenness constraints, greatly enhancing its theoretical foundation and practical relevance. Stick-betweenness constraints impose organized path requirements mirroring real-world physical limitations, while the introduction of penalty functions takes into account geometric and environmental costs. We propose a robust methodological approach that uses dynamic programming to create the best strategies for the pursuer and evader to handle the complexity caused by these constraints. So our framework ensures adaptability while offering a comprehensive solution paradigm by balancing strategic decision-making with geometric and physical constraints. This research provides valuable insights into the dynamics of constrained pursuit evasion games, paving the way for future studies on real-world adversarial interactions under complex geometric and cost consideration. So the keywords: lion and man game, penalty functions, betweenness property, stick-betweenness property, and dynamic programming. So introduction. David Gale's lion and man game is a classic pursuit evasion game in which a lion, the pursuer, and a man, the evader, move within a bounded domain, typically a closed disc. It was originally posed in 1925 by Redo as follows. A lion and a man in a closed circular arena have equal maximum speeds. What tactics should the lion employ to ensure his meal? The lion wants to catch the man, while the man aims to avoid being caught indefinitely. Both players have the same maximum speed and perfect knowledge of each other's position at all times. However, real-world pursuit evasion scenarios are more complex, involving imperfect information, dynamic obstacles, environmental unpredictability, and context-dependent layer objectives. To address this limitation and improve the practical relevance of this problem, we introduce a refined model that incorporates elements of realism and complexity, bridging the gap between theoretical elegance and practical applicability. In this work, we propose an extended version of the lion and man game that introduces two transformative elements: penalty functions and stick-betweenness relations. These additions significantly elevate the strategic depth of the game by introducing novel constraints and dynamic incentives that challenge conventional approaches to pursuit evasion dynamics. So in the classical formulation, the lion's primary objective is to capture the man, while the man aims to evade indefinitely. By incorporating penalty functions, we introduce a system of incentives and deterrents based on spatial proximity, capture timing, or deviations from optimal trajectories. These functions encourage players to adopt more sophisticated and adaptive strategies, rewarding efficient maneuvers and penalizing reckless. This extension compels players to account for advanced spatial awareness and path planning, leading to richer and more complex tactical interaction. Together, these innovations provide a fresh perspective on the lion and man game, offering new challenges for theorists and practitioners in game theory, robotics, and artificial intelligence. Our analysis explores how these extensions impact game dynamics, optimal strategies, and potential equilibrium, pushing the boundaries of pursuit evasion theory. This study aims to set the foundation for further explorations in the enhanced pursuit evasion games, emphasizing the importance of penalty-driven incentives and spatial reasoning constraints in fostering a more nuanced and competitive gaming environment. So the related work, the lion and the man problem, is a canonical pursuit evasion game. The first solution was generally accepted by 1950 in this paper. A detailed discussion of the solution can be found in these papers 13-15. Traditional formulations assume unconstrained movement and focus on optimal strategies for the lion to capture the man in minimum time. So such extensions are relevant in scenarios such as mathematics, control theory, due to application in predator, pre-dynamics, security robotics, or autonomous vehicle navigation, and adversarial planning, where constraints and penalties guide movement. Very similar games have appeared under different names in the literature, the robot and the rabbit. So these are the literature review. So in order to calculate the best strategies for both players while meeting the added constraints, our method uses dynamic programming. This expanded formulation offers a useful framework for simulating real-world situation with restricted settings and goals driven by penalties. Here we focus on a discrete time equal speed game. The domain X of a game is a geodesic space. Initially, the lion and the man are located at 2 points L0 and M0 in X. One fixes a positive upper bound D on the distance of the lion and the man may jump. After time t, the lion moves from the point LT to the point LT plus 1 along a geodesic from LT to MT. That is, the distance of the lion to the man is equal to the distance of the lion to which the lion will jump plus its distance where he jumps to the man, such that his distance to LT equals minimum of which he jumps and the distance of the lion to man. The minimum distance will be taken. The man moves from the point MT to any point MT plus 1 belongs to X, which is within the distance D. So given a metric space, we say the lion wins if the limiting distance of the lion to which it jumps and the man is equal to 0 for any pair of sequence LTMT that satisfies the previous metric condition for any D greater than 0, otherwise the man wins. In this section, we include, in preliminaries, we include a brief description of some notation and recall some basic definitions. So BXYZ means Y is between X and Z. And this has XYZ means that the elements of the set XYZ are pairwise different. And X dash Y dash Z, it means that Y is strictly between X and Z. So strict betweenness relation formalizes the intuitive notion of being between in an ordered or geometric context. Formally, a strict betweenness relation BXYZ, it is a ternary relation on a set X that satisfies certain axioms, ensuring logical consistency and mathematical ability. So, considering these first order axioms with characterization of strict betweenness relations, that is, if BXYZ means XYZ are pairwise distinct, and BXYZ that also Y, that means Y lies between X and Z means Y will also lie between Z and X, same thing. Now Y lies between X and Z is the negation of Z lies between X and Y. So BXYZ and BYZU, if we have these two betweenness relation, and this will tend to BXYU. Then BXYZ and BYUZ will give BXYU. So if XYZ are pairwise distinct, then B will have BXYZ or BXZY or BYXZ. Any of these betweenness relation will hold. So for all Y there exists X, there exists Z, such that BXYZ holds. If X not equal to Z, there exists Y where BXYZ is a betweenness relation. That means strict betweenness relation. Thus the definition of strict betweenness relation is this: for any three distinct points X, Y, Z in a geodesic space X, the strict betweenness relation BXYZ denoted by X dash Y dash Z means that X, Y, Z are collinear and that Y lies between X and Z excluding X and Z themselves. So some of the properties are asymmetry, transitivity, collinearity, irreflexibility, ordering, compatibility with line segment. Okay, so these are the fundamental lemmas and theorems. Uniqueness of betweenness. Then if X strictly less than is a strictly ordered set, then we define BXYZ if and only all these proofs are already given. I have taken from this paper one, that is okay. So these are the theorems. Now penalty functions. After 3 decades of studies following the early work of Jaeger, the current understanding of a penalty function is: let a closed interval I subset to R. A function P I cross I to the power n belongs to R positive is called a penalty function if there exists C belongs to R positive such that Pyx is greater or equal to C. That means the distance between the 2 points is always positive. And any x belongs to I to the power n where n is any natural number. And Pyx equal to C if x equal to y. And P dot x is quasi-convex and lower semi-continuous. This is the definition of penalty function. The function P star defined by P star Yx equal to Pyx minus C is a penalty function if P is a penalty function. Hence, C is irrelevant. The properties of quasi-convexity and lower semi-continuity of a penalty function implied that the set of minimizers of P dot x is either a singleton or an interval. This minimizer, the midpoint of the interval, is usually considered as the result of aggregation, which is returned by the so-called penalty base associated with P. So this is the definition of penalty based function. So penalty functions have been a part of the literature on constraint optimization also for decades. So in optimization process, the penalty function is defined as a function P r to the power n to r is called a penalty function if P satisfies Px is continuous on r to the power n, 0 if and only if it should have been x equal to 0, that is missed here, if x belongs to S, and Px strictly greater than 0 for all x belongs to r to the power n minus 1, where the considered problem is minimize fx, x belongs to S, where fx is a continuous function on r to the power n and S is a constraint set in r to the power n. Now dynamic programming. It is a newly developed mathematical technique which is often useful for making a sequence of interrelated decisions. It provides a dynamic procedure for determining the combination of decisions that maximizes all effectiveness. So the technique of dynamic programming was developed by Richard Bellman in the early 1950s. It states Bellman's principle of optimality in dynamic programming, which I have used here for the solution. It states that an optimal policy set of decisions has the property that whatever be the initial state and initial decision, the remaining decisions must constitute an optimal policy for the state resulting from the first decision. So the difficulty of finding a solution. So in a circular arena, the man has to stay within a limited area which favors the lion. If the man runs in a circular path, the lion could cut him off easily. So this is the picture. So the man's strategy should be, the man needs to find a way to efficiently run away from the lion in a bounded circular arena. The strategy he should follow is to connect the line between him and the lion and run perpendicularly to this line for a specified amount of time, because if he runs straight, the lion will catch him easily. So he should run perpendicularly. The strategy should be repeated at that moment. So this is the picture. The lion and the man, and he should run. The man should run perpendicularly. Since there are two perpendicular paths, we should choose the one closest to the center, or if the two paths are equally close, then either one is fine. To specify the exact distance the man should run in order he obeys the lion, we need to prove the following. The distance between the lion and the man is always positive. The man runs a legal path, that is, he always stays inside the arena. The man can continue indefinitely to pursue this strategy. So the notation used in this paper are capital R, the radius of the arena, VL, VM, the speed of the lion and the man, MT, the man's position at time t, LT, the lion's position at time t, DT, the Euclidean distance between the man and the lion at time t. So the problem setup, a lion and a man are there playing the game of pursuit and evasion within a bounded domain D subset to R square. We assume that initially the lion seeks to capture the man while minimizing movement penalties over time. The man tries to escape capture while avoiding violations of geometric betweenness constraints imposed by dynamic environmental conditions. So at any time in dynamic programming solution, first we have to define the state and then the
You have 2
value
minutes.
function. 2 minutes.
2 minutes.
And then let me go very fast. Okay, so I'm confused what to say. So this is the state of the game. RTL, theta TL, this LT is the position of, it is the lion's position, and MT is the man's position. And the strict betweenness relation forces the lion to reach certain positions before capture, and this is the penalty function. So I will go to the main. Okay. So example, I will show you an example in the figure. This is the figure. Okay, in this figure, where I have found a solution, the lion's position is this red dot. The lion is a red dot while the man is a blue dot. Both are point like to emphasize the movement dynamics. Penalty zones are the green squares. These are the green squares. Okay. Then lion's pursuit path are the red dashed lines, and the man's escape trajectory are the blue dashed lines moving outward. Okay. So converting the man's position is 7-7 and the lion's position is 0-0. So converting this into polar coordinates, we can find the polar coordinates means the radial distance, that is 9.9, which is nearly equal to 10, that means the boundary, and the angle, that is 45 degree. So the man must follow the following stick between. He cannot move towards the lion. His movement must always increase his distance from the lion. The man can only move outward. This restriction reduces the man available escape routes. Certain areas in the arena slow down movements, which is the penalty zone. If the man enters a penalty zone, his movement slows down, giving the lion an advantage. Man's optimal strategy is to maximize his radial distance from the lion. He avoids penalty zone that could slow him down. He heads towards the circle's boundary, trying to reach a safe escape. If the man moves optimally, he can delay capture but eventually gets caught unless he reaches the boundary. So the penalty zones positions are 3, 4, 5, 6, 6, 3. So this is the lion's optimal strategy. The lion moves to 7-7 by minimizing radial distance, and he can catch the man if he goes without going to the penalty areas. He can catch the man in 8 moves. Okay, so using this is the dynamic I have used. And one more problem I want to show you, that is lion's optimal strategy. If I take if the game is played in a circular arena of radius r equal to 10 and the initial position of the lion is 10-0, man's position is 10 pi by 4, that is the angular difference. The angle difference is pi by 4, and their the speed, if we consider it as 1, and the angular movement theta, I calculate the angular movement theta m minus theta l, then I have got this table. That means at 0 time lion position is 10-0, that means on the boundary itself, but the angle is 0, and man's position is 10 pi by 4, that is 7-7 if he stays in that pi by 4 I have calculated from there, and then that will be the distance. So this is the lion's optimal strategy, and the man's optimal strategy is because no time, I'm getting confused. So if the game is same game, if I take these values, if I get the angle difference in all positions, wherever the lion's positions and the man position be, the angle difference is all the same, that is pi by 4, and in that case the lion cannot catch the man and the man can run indefinitely. That means the lion can catch the man only if the angular variation is 0. And here, and in this case, the angle difference is pi by 4, pi by 4, pi by 4 in all cases. So in that case, the man wins, that means he can escape indefinitely. So this is my conclusion. These are lemmas and theorems which I am going to prove it for further. It is already there. Not already there in my this one. I will have to arrange it, and this is the conclusion. So thank you.
Thank you. That was a very nice, very interesting presentation. So any quick question? If there is any quick question. Mandeep, you want to? So I'm just curious.
Yeah.
So in your example,
Yeah.
instead of describing, writing so many things,
Yeah.
can you create a visual moving picture?
A picture, I have to learn that because this I have learned this TICZ, I have done these figures in TICZ, but this manual picture, lion and the man, I'll have to try that. I don't know how to draw.
It will be so
Interesting,
much easier
yeah.
to understand, more interesting.
But to draw the lion and the man, that is also
Because
I'll have to
now I
learn.
think there are animation things which are freely available, so you can actually prepare
If
one.
sir, if sir helps me out.
Anyway, thank you so much.
Welcome. Thank you.
So we will move to the second talk, which is supposed to be online, correct?
Yes, sir.
So So is the speaker online? Is he online yet?
Yes, sir.
So the next speaker is Manas Pratim Lahokar. So it's joint work with Utpal Sharma and Trivikram Pradhan. The title of the talk is Morphology Aware Byte Pair Encoding for Assamese Tokenization. Okay. So is Manas Pratim Lahokar present online?
Admit.
Hello.
Hello.
Can you show your face, please?
Surely, sir. Surely, sir. Let me turn
We
on my
can't hear
camera.
you. I think he
Hello.
is mute.
Hello. Hello.
He is probably on mute.
Hello.
Hello, Manoj. Can you speak again?
Sir, I am speaking. Is my voice audible?
You.
Say it's not mute here. It's not mute. That is an. Say there is some technical difficulty at keyboard.
Hello.
Come in again. Manoj, can you exit and log in again to the link, because you are
Surely, sir.
not audible to us?
Surely, sir. Surely, sir.
Manoj, can you try talking once more?
Sir, am I audible now?
No, you are still not audible.
Uh,
Can you check your speaker or something?
Sir. Zimit microphone. It says that it's working properly. Let me try with few other microphones. Am I audible now, sir?
Can you increase your speaker volume
Hello.
and try again?
Hello. Hello.
Yeah, now it is
Hello.
coming perfectly. Great. Fantastic.
Okay.
So are you ready? Can you share your screen?
Yeah, surely, sir. I am sharing my screen right now.
And when you are talking, you have to mute the other speakers.
Hello.
Yes.
Is my screen visible, sir?
Not yet. Not yet.
So just now I opened my presentation. Is it visible now?
Now it is visible. Make it full screen.
Yeah. Okay, sir. So shall I start presenting my work now, sir?
Can you make this full screen?
So it's already full screen now.
Full screen for you. Yeah, now it is great. So Manoj, you can start now. You have 12 minutes to present.
Okay, surely, sir.
All right.
Yeah. Okay, sir. Hello, everyone. My name is Manas Pratim Lahokar, and I am from Dibrugarh University. And today I am presenting my work, MA BPE, a morphological aware byte pair encoding for Assamese tokenization. So talking about tokenization, so the main importance of tokenization is during the pre-training of a large language models. So large language models requires effective tokenization. Traditional tokenization struggles with low resource languages like Assamese. So we can go for something like subword tokenization, like byte pair encoding, which balances vocabulary and also efficiency. So our work introduced MA BPE, a morphological aware tokenizer for Assamese. So what's the motivation behind this work is that Assamese is a morphologically rich language with complex suffixes. So existing tokenizers which are trained on high resource language often fail. So we do have some tokenizers which are already working in Assamese, but their output is very bad. While or we can say it's not. We cannot pre-train a model based on those available open source tokenizers. So our method aims to reduce the token fragmentation and also improve efficiency. So I went through literature before doing this work. So it shows that it highlights inefficiency in standard tokenization methods. So prior works in Swahili and Uralic languages show benefits of morphologically aware tokenization. So I got my main motivation from this work only, and there is no existing tokenizer which is optimized morphologically for Assamese language. So based on all these shortcomings and the motivations which I already talked, and the literature review, I came up with my work. So what my methodology does is that in my work, my methodology, the byte pair encoding, the traditional BP algorithm, it merges frequent character pairs, but it ignores linguistic structures. So what my BP did was, so I modified the original BP algorithm. So it integrates Assamese suffix constraints. So suppose I had a list of Assamese suffixes, so around 220 suffixes. I believe 210, it's not 220, 210 suffixes. So if a word is a suffix in my suffix list, my BP tokenizer will not merge those two words even if they are frequently occurring throughout my training vocabulary. So by doing so, my BP tokenizer respects the morphology of Assamese language and also converts my vocabulary into a subword tokenizer, which is much more beneficial than word-based tokenizer or character-based tokenizer. So it prevents incorrect merges and also enhance NLP performance. So although I have not checked about enhancing the NLP performance in the downstream work, but I am going through that part, and I am pretty confident that will surely enhance the performance in other downstream work also. So standard, I already talked about this thing earlier. Standard BP merges incorrectly, affecting linguistic coherence. So our approach ensures correct morphological segmentation while constructing the vocabulary in our tokenizer. So we collected a huge data set. So we used the common crawl data set, and there is one Sangraha dataset. So it's released by IIT Madras for that AI for Bharat work, and also we scrapped all available Assamese newspapers and we collected a huge corpus. Yeah, we can say it's a huge, based on since our Assamese is a very low resource language, but yes, comparative to other language, it's pretty small, but still it's huge for a low resource language. We had 12 million sentences, some 434 million words, and 1.18 million vocabulary size. So unique words, vocabulary size basically means I counted the unique words in my corpus. So it ensures diversity and it represents almost all available Assamese texts in online forums or online medium. So we use these evaluation matrices, tokenization efficiency. So it's mainly calculates the running time or the time which is required for tokenizing a text, compression ratio, normalized sequence length, and subword fragmentation. So these are the matrices which I used. So for the experimental setup, so what I used was an RTX 4070 NVIDIA, Intel i9, and 129 GB RAM. So yeah, this was a cloud-based system. So the resources was pretty high, and we tried different vocabulary size ranging from 1K to around I think 20K. So and finally we found the most optimized vocabulary size in around 10,210 tokens, and 2,210 were the suffixes and 10,000 were the vocabulary which was been extracted from that corpus. We compared our tokenization performance against GPT, Gamma, Mistral, and I think Llama. Yeah, Llama also we compared our performance. We compared the performance of our tokenizer, and among all among all the evaluation metrics, it outperforms all the available tokenizers in the market. So it's quite fast while talking about the tokenization speed, encoding time, and also the decoding time. So it outbeats all its competitors. And talking about this is the graphical representation of this table. It's the same data only. And talking about other results like compression rate, normalized sequence length, and subword rate. So it barely beats GPT, but talking about the other two models, other two open source tokenizers, it surpasses them by a huge number. So our tokenizer is the fastest one among all the tokenizer present. Mistral and Llama proved to be the slowest one, and it's quite unsuitable for Assamese NLP. The thing is that they break down the words into character level tokens, and basically it's just a character level tokenizer. I think due to the lack of training data and all those things, it just segments the word into characters. And the main key takeaway from our research work is that our work is the best present tokenizer in Assamese right now, I believe. And so it should chosen a very good architecture for LLM. It should also outperform other architectures if we pre-train with this tokenizer and then fine-tune it in other tasks. So the thing is that GPT Gamma all introduces fragmentation, all has fragmentation issues. But I talked about this earlier. Mistral and Llama are quite inefficient for Assamese language processing since they break down the words into some character level tokens. And talking about future work, I need to apply this. So this is just a tokenizer right now. So it's just the first stage. So we need to have, we'll use this tokenizer to break down the corpus into tokens and then train an LLM, or I think pre-train an LLM. Then we'll go for fine-tuning the LLM in many other tasks like translation, NER, and all those things, question answering and other things. Yeah, this is all for me. Thank you. Hello. Hello, am I audible?
Yes, you are audible. Thank you, Manoj.
Okay.
You have actually finished before time.
Okay, sir.
So are there any questions from the audience? Any questions, comments, clarifications? Manoj, can you stop the screen sharing?
Surely, sir, surely.
There is an infinite regression now. Okay, so good work. So I just have one clarificatory question. So when you are parsing, are you doing it word by word or sentence by sentence, or what is the length of your string that you are parsing?
Sir, it's character by character. Initially, all the unique characters in my corpus will be extracted. After doing so, then they will find, the BP tokenizer will find which two characters are most frequently placed together. So if two characters, then suppose they have a list of all the frequently occurring characters, and then they will merge that character into a token. So this kind of merging will go on till the number of vocabulary size is being reached.
So, but you are not looking at longer strings to see if there are higher order dependencies?
No, sir. Since this is just a tokenizer.
Some phrases are very common, so some words appear together, right?
Yes, sir.
So that effect you are not considering?
Not right now.
Even I think I have just a query in addition to what Professor Diganta has said. Like certain words, they have different meanings, but the same set of words, but they have different meanings. So are you considering those things?
Sir, this is just a tokenizer. As I talked earlier, this is just a tokenizer. The main purpose of this thing is to just break down the corpus or break down a sentence or a string into some kind of tokens. So these tokens will be fed into an LLM. So since they will have all those positional encoding and then this embeddings and all those things, surely the dependencies which you are talking about, they will be met in that upper structure of this of the LLM. So they will surely be dealt with. But right now, since this is just a tokenizer, even if two words are placed in different contexts, they will have the same number.
Okay.
But their surrounding words or their surrounding words will decide what kind of meaning they will carry when they will be fed onto that LLM.
Okay. Thank you, Manoj. So if there are no other questions, let me thank you once again.
Okay. So I will turn off my camera.
Yes, stay with us because there will be a concluding comment or something. Oh, from me?
Surely.
Okay. so I'll just take 1 minute. So we have listened to two presentations. Both are interesting and very different. It would be nice if the audience participates more, ask questions or make comments. I believe that most of you are students of the department here, right? In the audience, huh? of the university. So the students should be more participating. Huh? But anyway, it has been nice, and let me thank both the speakers once again, Ranumoni Borua and Manoj is still with us. Yeah, Manoj Pratib Lahokar, both are with us. So thank you so much, and let me conclude the session.
Thank you, sir, for your insightful concluding remarks. Your words have provided us with a valuable reflection and key takeaways from this conference. We sincerely appreciate your time and presence here today. Apart from them, we'd also like to thank both of our participants, Ms. Ranumoni Borua ma'am and Manas sir, for such a wonderful presentation. Now, as we move ahead for the program, I would like to formally conclude this event. So I would like to invite Professor Kaushik Das sir to deliver the vote of thanks.
We are coming to the last agenda, that is the vote of thanks. So I would like to take this as a privilege for allowing me to deliver the vote of thanks. So I, Shri Kaushik Das, would like to thanks all the speakers. Professor Nityananda sir, he is my teacher from Tezpur University. I pursued MTech from Tezpur University, and he was teaching mobile computing to us. We are very much happy to find sir with us, Professor Diganta Mukherjee sir and Professor K.S. Mallikarjuna Rao sir, who has directly reached our venue from Dibrugarh Airport, I think so. So, and we also thanks to our patron, Dean Student Affairs, Professor Surajit Borkotaki sir, for giving us time from his busy schedule. I would also like to thank all my colleagues present over here, especially my research scholars and student friends. But as our expert has already said that this platform is open for all, so you should not feel shy and you should be more interactive, and then only with some kind of queries, if there are queries on your mind, then you should definitely share. So tomorrow we would like to expect some kind of more interactions. But the heartfelt thanks to all the participants, and today in this session, in this track, only 2 participants have presented, although there were more numbers of authors who had submitted the papers. I hope in a parallel session there are actually other authors who are presenting, and I have heard that the sessions are going on well. So I would like to thank all the technical staff, the senior laboratory instructor, the laboratory instructor, all the staffs and my organizing teams with volunteers, without whom this event was not successful on today, that is the first day of the Today National Conference. I request all the students to please reach tomorrow 9 a.m. positively, have your breakfast, so that we can start the session from 10 a.m. sharp. There are 3 venues tomorrow: Duet Mini Auditorium 1 venue, Department of Computer Science and Engineering 1 venue, and next venue is Department of Mathematics. So a notification has been issued, though tomorrow is a holiday, but tomorrow is open for us. Please make sure you have to stay here. And I think attendance will be compulsory, as the HOD has already issued the notification. So thanks in advance that you will be present here. Okay. Thank you once again to all my teachers and experts. Thank you.
with that, we have come to the end of this enriching and insightful conference. It's been a privilege to host such esteemed speakers, researchers, and above all, participants who have contributed for meaningful discussions and knowledge exchange. So, wishing you a wonderful evening ahead. Now, I would rather ask I would ask all the guests to join us for some refreshment and tea. And please, students, be present tomorrow at 9:30 sharply.
বেটেৰীখিনি কি হ'ল 7 ঘণ্টা 2 মিনিট আৰু এটা বস্তু বেটেৰীখিনি কোনটো হেৰি ক'ত গ'ল বেটেৰীখিনি কি হ'ল তাতে আছিলে ষ্ট্ৰীমেন হৈ গ'ল